Welcome back to day 4 of the AWS Certified Solution Architect Associate 2022 Bootcamp. And this is a completely free, full AWS course. So again, welcome back to the AWS Certified Solution Architect Associate 2022 free bootcamp from Go Cloud Careers. This is something we do at Go Cloud Architects and Go Cloud Careers to help you build your absolute best career. That's why we do these boot camps. We run them live and we run them free. So we really want to help you build your best career. We'll begin in a few minutes. First, for the people that celebrate it, happy Good Friday, everyone. And happy Easter for those people that celebrate Easter. Now there's other Easters. So for the Greek people, when we all celebrate our Easter later, happy Easter for them. Happy Passover, which begins tonight. Happy other holidays. So really excited to have you back here today. So today we are on day 3 of the AWS Certified Solution Architect Associate course. And if you could start it out by saying you're here by typing a cloud hired. And also if you can tell us where you're at, we love knowing it. We love knowing it. Now, a couple things that I want to let you know. Along with this course, we have a full set of labs for you to do. I focus on more of the architectural considerations and how things work and why things work. But if you desire to be a cloud admin or a cloud engineer, you got to get your hands dirty, and we've got a set of labs for you to do. Again, it's completely free. Download them. The link is in the description below. We've got a full lab course for you where we walk you through how to do these things. So get hired. Now, I'm going to tell you some other good news. We extended our sale until the end of the weekend. Here's why. I got about 30 emails this morning that said, Wyke, I really want this course. I watched all your people get cloud hired, but I can't do it for another day or two. Can you extend it? So I asked Chris on the back end. He extended the coupon for a couple more days. So throughout the weekend, you can still get our cloud architect class. You can pre-order our cloud engineering class. You can get our interview training program if you're trying to interview. Or if you're already working in tech and you want to move up the tech ranks, become an engineering manager, a distinguished architect from a regular cloud architect, or move into management or leadership positions, we've got the Tech Interview Mastery Program. So now's your time. 30% off. Let's get you all cloud hired, cloud promoted, and build the best career. Just want to help you all get cloud hired. So we extended the sale, and I wanted to tell you, guess what? Brand new news. We've launched a brand new cloud engineering program. And this is where I get to get real geeky. And we had some really incredible people help us put this program together. Since cloud architects were system designers, we've been getting people cloud hired every day as cloud architects, and we love it. But now we're going to train cloud engineers. Cloud engineers need a completely different set of skills, so they'll have to know how to build things. They'll need to know how to code and configure. They'll need to be experts in Linux, and they'll need to know Terraform, and they're going to be experts on building their own clouds. So the cloud engineering program. If you want to be a cloud engineer, or you know somebody who wants to be a cloud engineer, you're going to get cloud hired as a cloud engineer, and you're going to love it. And you'll be ready on that first day of the job to not only get hired, but you'll be good, you'll be strong, and you'll be getting promoted through your career. So now we've got a cloud architect program for you and a cloud engineering program. Guess what? A cloud Linux engineer is coming soon too. And here's why. Everything is Linux. All the world's most important computers are Linux. And we don't just teach Linux. We take somebody that used to work at Red Hat and we hire them to teach Linux. And that way we get the best. Now, the person that we hired to teach our Linux was someone that I coached many years ago who went on to Red Hat, became an architect at Red Hat, and knows a million times more than I'll ever know about Linux. And that's why we hired him. We've got Terraform, so it's going to be really great. So the cloud Linux engineer, cloud architect, cloud engineer, all coming. And today, I'm very proud to announce that we've created a program for the military. Someone to take people from the military and get them all their first 6-figure jobs in the civilian world. It's a program that will address the military to civilian leadership changes, the needs of those of us that come from a tactical background where we've had lots of stress in our lives. We address that. And we teach all the skills to get you hired, paid well, promoted. And there's no veteran that we feel that you get less than a 6-figure job upon leaving the military. And we've got a program to help you achieve just that. And we're real proud of it. So now you know what we've been doing. Now today, we're here for day 4 of the AWS Certified Solution Architect Associate 2020 Bootcamp, and we're excited. There's a companion ebook that goes along with this. Complete and total book that'll help you with this exam and also help you with the AWS Certified Solution Architect Professional if you completed the AWS Certified Solution Architect Associate 2022 program. And guess what? It's completely free, and the link is in the description below. So as you can see, all we do is try and help you get cloud hired. On Cloud Monday, we'll come back and answer any cloud architect career questions or cloud engineer questions you have. And then on Thursday next week, we have our famous How to Get Your First Cloud Job webinar. All of this completely free to help you get cloud hired. So without further ado, we will get to the context. So, let's see who we've got over here in the room. I see we've got some people in Nigeria, California, New Zealand, loving this. Atlanta, California. Marla's over in Atlanta. Marla is incredible. The ebook is your best friend. Yes, I completely believe you. Tata, my good friend from Cloud Heroes Africa, welcome here. I haven't spoken to Samoa in a day or two, but I know you're part of that wonderful, wonderful community, and I love being part of that as well. So welcome, welcome, welcome. And if you're from the We're Friend group as well, we're thrilled to have you here as well. So today we're going to talk about getting cloud hired. Now, I spent lots of time in Philadelphia, and I spent lots of time in Phoenix. And Marla, I'm thrilled to see you. And Mufaz over there in Nigeria, we got to get you hired as well. And we got to get Philomena hired in Georgia, and Kate Talley in Alabama. So yeah, fantastic, fantastic. Kevin's over there in Cameroon. We love people in the Cameroon. We love people all over the world, but we do a lot of work in Cameroon, and we love it. We do a lot of work in Nigeria too, and South Africa. We do a lot of work all over the world. So Angelo or Aguilo, depending upon which country you're from. Happy everyone, and Bebito, one of my wonderful students over there in Houston, cloud hired. So we're super thrilled. We're super excited. We're going to get through the content today. And, we may have to go for some more tomorrow because it's, a lot of content to cover, but we're having fun. I hope I'm having fun. I hope you're having fun. And Calpsoni, we are super excited to be working with you. And we think you're going to have an incredible time with it. So can't wait to work with you. Can't wait to see you in class. I love when people come to class and they're on Zoom and I can look at them and we can talk. It really changes everything. So excited to work with you. LM, you're here and you've got a friendly ghost with you. I love that. There used to be a cartoon when I was younger called Casper the Friendly Goat. So we're going to get back to the AWS Certified Solution Architect Associate 2022 course, which is a free full AWS course. So in this section, we're going to talk about security. Now, please understand, we're talking about AWS security because this is an AWS certification exam. No. The way we do security in reality versus what we're teaching here may be very different. So when the time comes, I will actually go through the differences between certification training versus what you actually do in the real job. And you'll see the differences because you need to know both. We'll talk about it. So under the security section, we're going to have a lot of fun. We're going to talk about a lot of stuff. We're going to talk about who is responsible for what part of your virtual private data center. We will talk about something called the principle of least privilege, which I like to call need to know. We'll talk about industry compliance. We'll talk about authentication, authorization, and accounting. We'll talk about these multiple account strategies. We'll talk about network ACLs, security groups, and basic cloud native firewalls like WAF. Then we'll probably tell you what you can do instead of WAF when your customer security matters. We'll talk about intrusion detection and prevention, DDoS attacks, service catalogs, and the systems manager parameter store. So we're going to get into a lot of whole AWS Certified Solution Architect Associate content and AWS Certified Solution Architect Professional content here. So the first thing that we're going to discuss is who is responsible. And let me tell you, this causes problems all over the world when it comes to cloud architecture stuff and security. And this shared security model may be the biggest cause of 50% of the problems, and here's why. With regards to your cloud providers, and they all have a shared security model, you and the cloud provider share security responsibilities, and it's not necessarily the most clean, defined thing. So the cloud provider, like AWS, will maintain the security of their cloud. You maintain the security of your virtual private data center. Now, if the cloud provider doesn't secure the cloud properly, here's what's going to happen. Somebody's going to hack into the cloud and they'll get into your secret private data center. So keep that in the back of your mind. The cloud is always more risky than the data center. And here's why. In the data center, we've got some attack vectors. Internet, internal users, etc. We know what they are. On the cloud, we have those identical attack vectors. None of them change. They're the same. Internet access users, etc. All the same hackers will deal with them both in the data center out on the cloud. But on the cloud, if the cloud provider gets hacked, we get hacked. And the cloud is a bigger, higher value target because hack into AWS, got access to millions of customers. Hack into mycatcindy.com, guess what? You get access to mycatcindy. So on the cloud, we have more risks. Now, the cloud providers will tell you they're more secure because they have more modern infrastructure. But here's the key. You can lock down your data center far more secure than you can in the cloud. And for organizations that need really deep security, some of them will do certain things in the data center because of this. But in this certification course, we're teaching you how to do security on the cloud. And for certification purposes and for business purposes, we're going to say that the cloud is essentially equally secure as the data center, because for the most part it is. But under the shared responsibility model, and here's where it gets challenging, the cloud provider manages the security for your cloud and you manage your VPC, but there's a lot of overlap and things get kind of ugly. So keep that in the back of your mind. So what does that mean? It means the cloud provider is securing their network. You have no control over it. So if they don't do a good job, you're in trouble. Versus in the data center, you control it. But let's assume the cloud provider builds the perfect network. Let's assume they have the perfect routing. Let's assume they have the perfect firewalls, the perfect intrusion detection, intrusion prevention systems, the best access list, security groups. They've optimized their servers. They've hardened their systems. And let's pretend they're perfect. Let's just make that assumption. Nobody's perfect, but there's that. And now you know the thing. So we manage the users and the users' accounts. We manage patching our operating systems. We manage the firewalls in and out of our systems, the IDS, IPS systems in our systems. We configure whatever AWS security options we can use, or we can go to the marketplace and get robust enterprise security options like Palo Alto things or Cisco things. And we also must manage the physical device that connects to the cloud. So here's the thing. If you've got a data center and it connects to the cloud over a wire or a direct connection like this, if somebody can just walk into your data center and plug in a cord, guess what? They're in. So this morning, somebody asked me, hey, Mike, you think I can go visit a data center? And somebody will explore it. I'm like, well, no, because once you're in the data center, you just violated their security. They can't let you in. So it's kind of one of those kind of things. So the data centers need to be locked down and secure. So what's it really look like? It's going to look like this. In this particular situation, here's what you can see. The cloud provider, in this case, AWS, they manage their physical servers, their storage, their own physical databases, and their own networking. They're dealing with the hardware, the physical network cards, the GPUs, the CPUs, the DRAM, the routers, the switches, and the fiber connections. That's the stuff that's there. They're managing the hardware, the physical load balancers. They're managing the regions. They're managing their data centers, availability zones. They're managing their content delivery network or edge locations. They're managing their other points of presence where you come in for edge computing, such as the local zone. They're managing all of it. But what are you managing? Well, that's where it gets tricky. You're managing the customer data. You're managing your firewall or operating system tuning. You're managing the client-side encryption. You're managing the server-side encryption, the traffic protection. So you're basically managing the stuff in your virtual data center, and they're managing the physical data center. So for the most part, you have to maintain almost as much as you did before. So now you know the shared responsibility. You're responsible for your VPC, or your virtual private data center, cloud, whatever you want to call it. They are responsible for the physical infrastructure. So now you know. So make sure you do your part. And if you do their part and if you do your part and they do their part, we should all be in pretty good shape. So we're going to just keep it that. So keep that in the back of your mind. Now we're going to talk about the principle of least privilege. Now, this is a very common security thing. It matters whether you're in the US, it matters whether you're in the UK, India, everywhere in the world does it. Guess what? It matters in the military too. The military calls this need to know. And I think that's a much more appropriate term. What does it mean? If you don't need access to the information, you don't have it. Why? If you don't have access to unnecessary information, you can't hurt the business. So Need to know is the better term for principle of least privilege. And what is it all about? It's about giving people access to only the information they need to do their job and nothing more. And here's why. Let's say you give access to information, and then that person goes and works for your competitor. They can give critical information to your competitors about your intellectual property. So in organizations, the executives and the leadership know the most. And as people get less trusted, they learn less and less and less. So different people need access to different things. So if you're in a help desk, you might need access to reach people's systems. You might need good access. Likewise, a systems designer like me or a cloud architect like me, I don't necessarily need access to half of these systems. I need access to the executives telling me what they need. When I bring in my cloud engineering team to do a proof of concept, they're going to need major access, and I'm going to get it when they need it. But once that's not needed, we're going to revoke it. So principle of least privilege, need to know. You need access to this? Here you got access. You don't need access to it anymore? Poof, access cut off. So principle of least privilege, otherwise known as need to know. I use need to know. It works out much better. It's a military term. I understand it. That's kind of the same thing. So when you log into a Linux system, you don't log in as root. For that reason, you can break things. But logging in as root is you protecting yourself from doing something silly. This is basically making sure that other people can't damage the integrity of our system. So give people only what they need. The second they don't need it, take it away. Then you'll be in good shape. So visually, what's it look like? And principle of least privilege is going to be used with something called authentication, accounting, and I'll talk much more about that later. But really what it's based on is this. Here we've got this blue person on the top, and they're an administrator. They need access, so they get access. They go through, they get authenticated and authorized to do whatever they need. Good to go. And they're given information. Now I got this user that we're requesting access to something they don't need. Blocked. Why is it blocked? There's no reason to do this. So you will see this multiple times on your exam. They will call it the principle of least privilege, but I'm going to tell you it's need to know. And if you remember, if you don't need to know the information, don't give it to the person, you will be in good shape. So I like to keep things simple. Need to know means principle of least privilege. So whenever we're dealing with tech, and we're dealing with industries, there's always some kind of crazy regulation. And regulation is designed to make things cleaner, more legitimate, more efficient. And whether it works or not, that's neither here nor be there. But there's a lot of industry compliance standards. In medicine, we have HIPAA, which is basically about who can learn what information about whom in healthcare. If you want to deal with the US government, there's something called FedRAMP. You're dealing with payment cards, there's a PCI DSS. You're dealing with the International Standards Organization. We're dealing with things like the Standards 9001, 27001, 27017, 27018. Anyway, there's a list of these security industry compliance things. GDPR regulations in Europe, there's a million of them. Here's the key. AWS, like most good cloud providers, supports the critical industry regulatory compliance. Guess what? So does Azure, so does Google, so do all your main players. But realize that if you're dealing with an environment that requires industry compliance, you can do it on the cloud providers because they got themselves certified to do so. Now, the next thing we're going to talk about is a term I absolutely hate. It's called identity and access management. And what does that mean? Nothing to me. So I'm going to define identity and access management under what we used to call them before we created fancy inflation in technical terms. We used to call it AAA, which meant authentication, authorization, and accounting. And identity and access management is 100% authentication, authorization, and accounting. So what is it is? Authentication, who are you? So let's see who's got a blue wrench that I can see from the chat box. Leo Paredes has a blue wrench. So here's what it comes. Leo wants to enter the system. When he logged in today, Leo entered a username and password and identified himself as Leo. And because he was allowed Leo, he's logged in as Leo, he's got a blue wrench because he's got an account named Leo. Now then, when Leo goes to type something, like he did over there when he said vote on the next bootcamp, which I'm very grateful for. When Leo goes to type something, is he allowed to type? That's referred to as authorization. And then afterwards, I want to see what Leo Paredes did. Here's what I can do. I can see the logs of what he did. So identity and access management is determining who you are, what you're allowed to do, and then keeping track of it. And that's all IAM, or identity and access management, is. Who are you? What are you allowed to do? And then logging or keeping track of it. And once you think of it that way, and you get rid of the silly terms like identity and access management, you'll understand it and you'll be successful. So, and you're dealing with customers, you're dealing with executives, you tell them identity and access management, they're going to laugh. But if you say, look, we need a protocol to determine who your users are, what they're allowed to do, and then keeping track of what they've done, guess what? Now you're talking something that executives work. So if you're an architect, like a cloud architect, we recommend using the term authentication, authorization, and accounting, and describe it to it. Authentication, who are you? Authorization, what are you allowed to do? And accounting, what have you done? So, we're here. Now, when we're dealing with these identity and access management or AAA things, everywhere there's the concept of users and roles. And here's the thing. And I'll give you a little bit difference of this, but AWS calls a user a person. I'm a user. Chris is a user. Now, there's a concept of one system accessing another system. So let's say you've got a web server that needs to access a database. Now, there needs to be something in between them. Now, traditionally, in the compute world, when you go from one system to another system, it's called a service account. And if you were in the Google Cloud, it would be called a service account. And if you went to Red Hat Linux and you wanted one system to talk to another, it would be called a service account. But with AWS, in most cases, at least for the associate level, an IAM user is a person like Abigail or Leo or Phil or Sharon, or at least it's over there, or Aguilo. Now, by comparison, a role is a system attaching to another system for the most part. Now, there's cross-account roles and other things, but for the most part, an IAM user is a human, and an IAM role is a system accessing another system. And if you see a test question that says, what is the equivalent of an IAM role in Google? It's a service account, as it is for the rest of the world. So AWS made up the term IAM role. So you've got an EC2 instance, or a virtual machine accessing something. Now you're talking about an IAM role or a service account. I don't care which term you use. So let's walk through it again. Authentication. User signs in. Guess what? I sign in with my username and password. My username is Mike. My password is Cindy. Obviously, it's not, or I wouldn't talk about it. And I would have no password with any variation of Cindy. But let's just say my username is password. My username is Mike, and my password is Cindy. So I sign on with this. Now, I may have the system send me a message, whoosh, Mike asking for a one-time password, which would be two-factor authentication. But we could just enter the name Mike and the password Cindy, which would be totally stupid, and we don't have any passwords like that anywhere, but that's neither here nor there. So then we've got a user that authenticates to the system with his username and password. And then guess what happens? The user tries to delete a file. And then we look. Is the user allowed to delete a file or access that resource? If so, yes. If not, block. And then so I like to use this in the position of people. So I'm going to pick somebody that I know, someone with a blue red. So Abigail comes to Florida with her cat Noni, and she comes to Florida and she wants to visit me. Now, I know Abigail. She's one of my students. She's a great blockchain engineer, great blockchain architect, and a great cloud architect. She's great in many ways. So many good things to say about Abigail. So because I know Abigail and I trust Abigail, here's what I do. I say, Abigail, I want you to come to Palm Beach. When she gets to my house, she knocks on the door. I give her a handshake. My wife gives her a hug, and she gives her keys to the house and keys to my car. And my wife says to Abigail, welcome, Abigail. Welcome, Noni the cat. You're here. Here's Mike's Mercedes. You have the keys while you're here. Here's my Toyota. You have the keys while you're here. I bought all your favorite foods for the refrigerator. and just keep track of things, lock the door when you leave. So in her case, I knew Abigail. So what did I do? I gave her effectively privileged access to everything. Now, 24 hours later, there's a knock on my door. And the knock is from somebody that says, Mike, I want your cloud class. And I say, okay, I don't know who you are. How'd you find me? And they said, I saw you on the internet. I flew over here from Thailand last night, and I'm at your door because I want to talk to you. Now, I'd be so honored. I'd love to talk to this person, but I'm not giving this person the keys to my house. I'll say to the person, I'm so honored you're here. And now let's go out to lunch. I'll buy you lunch and we can talk about your goals. And see, why would I do that? Because I wouldn't give someone that I don't know privilege to enter my home. So for that, I just wanted to make sure you understood it. So that's what we're talking about. Principles of least privilege. Need to know who you're giving access to. You're giving access to what's appropriate for the person to be successful, and no more. No mas, any way you want to say it, no more. So now let's talk a little bit about IAM users. And an IAM user is an identity person who has the permission to interact with a resource. Okay. Now, who creates this? So basically, you need administrative access. So, which is called a principal. You need anybody that uses a system as a principal, and you need administrator access. Now, with administrator access, I can make an account for Chow, make an account for Leo, make an account for Chris, make an account for Abigail, or whatever I need. Now, a user can be created. I can create a user account on the management console, of course, CLI, or I can push it via an API through the software development kit. And now this is really important to remember. IAM users are permanent until you delete them. So you hire someone. They're a super user. They need access to everything. You give them access to everything. Then you go to your competition. You cut that access off instantly. Instantly. And in a good organization, the second they've determined that you're not working there anymore, or you've determined you're not working there anymore, within minutes, all your systems accounts are locked down. You can't leave the systems with your access to your information, and it's all locked, and more locked. So kind of keep that in the back of your mind. So let's talk a little bit about more and give you a graphical interface. So here we've got a user that wants to access a virtual machine, some object storage, or a database. They log in with their user account, and if they have permission, they get access. And if they don't have permission, they don't. That simple, that simple, that simple. So we're going to get into some IAM user concepts next, and it's going to be some cool and some fun stuff. But let me do this. We've gone for about 20 minutes. And because of about 20 minutes or so, then what do you call it? Let's ask some questions. So Cecile, is the principle of least privilege an exam question? I would assume it would be until proven otherwise. But more importantly, it's a critical thing for your job. Question. What's your advice for temporarily allowing a team to use root in order to get their project work started? Never do that. And then tune to control. So I'm going to give my users access to whatever they need. I'm not going to give anybody root. I'm going to give administrator privileges, which are slightly different than root. Or maybe power user privileges, and we'll talk about that. But a power user can do everything other than create IAM accounts. So generally speaking, I don't use root for anything. And the root of your account should never be given to anyone, anywhere, anytime, because they can completely delete your account. And you could have an organization that's got everything on a cloud, and somebody with root account can literally take the whole thing down. So it's never recommended to log into root. There's times where you have to super user to root in Red Hat, but if I still do sudo minus, I still would do a sudo instead of a super user whenever possible. And never, never, never give root access to anybody other than you, if you're the owner of the account. Liz Nan, should you know the compliance regulations? Well, no. But when you work with it, you do. So, for example, I design healthcare architectures. I know the HIPAA requirements. Why? Because it's critical to my world. Now, HIPAA talks about who can access what information. So HIPAA says that if some provider has a business relationship with another provider, then they can talk to each other. Now, what does that mean? It means that if I'm dealing with my patient from an internal medicine perspective, and I want to send my patient to a cardiologist for a cardiology consult, I can send the patient to the cardiologist. I send my chart to the cardiologist, and the cardiologist will see the patient, evaluate the patient, and then send me a letter. Michael Gibbs, thank you for the opportunity to consult on your patient. Your patient, Jeff, is a really nice man. Upon evaluation, Jeff had EKG changes in lead 2. Most specifically, he had a Q wave, which is indicative of a previous heart attack. Now, that cardiologist sends me back that letter, and he's allowed to because he and I are involved in my patient's care. Now, if that cardiologist says to his wife, hey, I saw an interesting case today, and shows that patient chart, well, that cardiologist gets sued, loses their medical license, and is done because the cardiologist is allowed to share it with me because I'm involved in the patient's care, but they can't share it with anybody outside of the patient's care. Now, if they send the patient for cardiac rehab, again, they can send it to that person because guess what? They have a need to know that information. So that's what you only need to know that when you're working on individual architectures. You will need to know the standards to make sure they're compliant. Difference between a user and a principal, we're going to get into that in a minute. Cecil, where are the accounts stored? Now, here's the thing. It's always going to be in a database-like structure. So you can store it in the AWS environment, and they won't tell you what their backend is. Or, Cecil, what do people really do? Nobody uses AWS IAM. Nobody uses Azure IAM. They use Active Directory for their enterprise. And they federate their Active Directory into the AWS or the Azure IAM or the Google IAM. So most likely you'll be setting up an Active Directory server in your enterprise. There's typically an Active Directory server that's responsible for the domain, the users, and the users' permissions. And then the cloud would just connect to that. Otherwise, we'd be crazy and we'd be manually entering usernames and passwords all day long. And now I see you won't have any problem with that. And then, Chris, you can go to the next one. Will I be discussing policies? Yes. JSON files, I'll briefly talk about it, but I'm not a software engineer, so I don't write JSON policies. I'm an architect, not an engineer. So, Brian, I don't make JSON anything. But the cloud engineers do need to know how to do this. Is there a way to transition, integrate on-premise Active Directory? Yes, absolutely. It's called AD Connector. And it's what 99% of all organizations do. Absolutely. You connect to it with SAML 2.0, and they typically cover it on the professional exam. We'll probably touch upon it here a little bit as well. Good question. Okay, so we'll get back to the content, but before we do, if you can give me all a hashtag cloud hired, because everything we do is about getting people cloud hired. We hope you're enjoying day 4 of the AWS Certified Solutions Architect Associate full free AWS course. So while we're going through the course and we're having lots of great time, remember there's a free book to download. The link is in the description below. And if you give me a cloud hired and a cloud architect, I'll be all kinds of happy. Oh, actually, while we're at it, I'm really bad about asking for this because I don't know how to be Mr. YouTube, but I truly do. If you're enjoying our content, if you could leave a like, if you can subscribe, if you're not a member, tell others about our channel. We want to get the world cloud hired, and we'd love some of your help in getting the world to know about what we do. So please like, comment, and share. Helps us with the algorithms and things like that. So let's talk about some key IAM concepts now. Now we're going to talk about a principal versus a root user. See, I told you we'd get here. And a principal is an IAM entity that has access to resources in the cloud. So anybody or anything. It can be a root user, an IAM user, or a role. So the person that owns the account, anybody that can use has access, or a system accessing another system. So let's talk about the root user. So if Tom Orpheus is there, Vasilikos is what the root user is. For any Greek people, for the non-Greek people, Think of the root user as the king. So when we're dealing with the root or the queen, when we're dealing with the root user, this is when we first create the account. This is the El Primo user. This is the king, the queen, and everywhere in between. Root has access to everything, and you can't lock it down. So root access wants to delete your entire cloud systems. Guess what? They can do it. So do not use your root user unless you need it. Take your root user credentials, pop them on an encrypted thing, stick them in a safe, put the safe in another safe, get 3 armed Navy SEALs outside and protect those root users like your life depends on it. Never, 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 ever give them out. That's how strong you got to protect your roots. So don't use it for daily things. Now, the passwords on your root account, they're not going to be like CINDY for the cat. They're going to be like 1742 equals 69432 hashtag bang, 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 $, greater sign, CAK going on. That's what a password for this is. And once you get past a password like that, you should have multi-factor authentication on this. And definitely don't use it as a service account to allow one system to allow another system. This is that critical. Lock it down like your life depends on it. Because guess what? If you're designing a system for a hospital, people will die if the root user comes out and somebody damages the system. People will die. So protect the root user like somebody's life depends on it, because in some industries they will. And that's why we have to be really serious with our architectures. Imagine somebody breaks into a hospital and they change 2 milligrams of IV morphine for a chest pain patient to 20 milligrams of IV morphine. That patient's going to stop breathing in 5 minutes versus having their pain relieved. So when we're dealing with mission critical systems, military systems, healthcare systems, it's a matter of life and death. When we're dealing with banking, it's a matter of minutes of downtime, could be billions of dollars. So in these highly important environments, security matters. And it's critical to get it right. So now you know about a principal versus a root user. So here's the way I see it. Here's your root user. The Vasilina, which is the queen, the Vasilikos in Greek, which is the king, queen, anywhere in between. I don't care what you would choose, but that's the key. This person is in charge, and that's why they're wearing the crown. And they can do anything they want. So use it when you need it. Keep it locked up the rest of the time. Now, a little bit more about IAM, Identity and Access Management, which I like to call Authentication, Authorization, Accounting, and then I understand what it is. I'm not big on complicated terms. I'm big on practicality, as are your executives. So your Identity Access Management will determine who can access the system, what they're allowed to do. So you got a couple ways you could do this. So here's the ridiculous way. I got a user for Chow. I make Chow an independent user. I make a user for Leo. I make a user for Chris. I make a user for Mike. I make a user for Cindy the cat. I make a user for Abigail's cat named Noni. Beautiful, beautiful, beautiful cat. And if you guys ever want a cat calendar, let me know in the chat box. Type cat calendar and I'll send you some beautiful cat photos. But that's neither here nor there. And we're just sort of having fun with it. But if you want a cat calendar, put cat calendar in the chat box. I got some cat friends that are professional photographers that want to make a cat calendar. So got to keep that in the back of your mind. So you got 2 ways you do it. So I could go to this group right now, and I could, if I wanted to, I could create a username, an account for Sharon J, then a different one for Carl, and a different one for Netacent, and a different one for Bibita, and a different one for Philomena, and a different one for Robert, and a different one for Segun, and then Eddie over there in Cameroon, I give him another one, and Philomena over there in Atlanta, I give her something else. You see, this would be a disaster, a total disaster. And yet I think we need to make a cat calendar, actually. So there's neither here nor there, but that's something going on. But when it comes from an identity and access management, you could create a user, or what could I do? I could create a user group called Blue Wrenches. And I could give the Blue Wrenches a set of permissions. And Leo and Abigail and Chow and Chris and me, we would all have the same permissions because we're all Blue Wrenches. Well, that's so simple. Create a Blue Wrench group and just add the users to it. And that's what people do. So what typically happens is you create a user group for your finance team. Then you create a user group for your accounting team. Then you create a user group for your HR. Then you create a user group for your programmers. You create a user group for your network engineers. You create a user group for your cloud architects, a new user group for your cloud engineers, because they all need access to different things. And that way, you're doing this. Because imagine a company with 200,000 users. You're just going to like, here we go. Mike gets this. Jesse gets this. Cindy gets this. Noni gets this. I mean, it'd be ridiculous. Now, the reality is what you're going to do is you're going to be setting this all up in Microsoft Active Directory and federating it too. But no matter what, understand, just like in Active Directory, just like in Radius servers, we have the concept of users and groups. You could, if you wanted to, literally make a policy for every single person to make it different. Or you can make a policy for a job or a role, and it's called role-based access control. So finance gets access to this. Accounting gets access to this, and that is the simplest thing to do. I'm letting you know that's what 99% of all organizations do. Because they're not crazy, and they need to make it as simple as possible. So let's look a little bit more the way this works. So how does it work? Well, you create a group. You give permissions to the group, and then you just add the users. So group, blue wrench, permissions, type in the blue wrench chat box. Delete inappropriate comments made by bots that are showing inappropriate things. And then I add the users to the group, and my blue wrenches are doing a great job. So love my blue wrenches out there, and super appreciative and grateful for all the awesome blue wrenches that we have. But now you know why. So let's get a little deeper. So if an IAM user is a human and a role in AWS is a system, until we start getting into federated things where things get complicated, we have to remember that roles are different. Now, there's going to be a couple kinds of roles. There's going to be a service role, which is how do you connect one system to another. Your application server at a DynamoDB or an SQSQ, that's a service role. A cross-account role is, hi, I'm Go Cloud Careers, and we've just found another company and we love them, and I have access to their system. We give them some access to our system. That's a cross-account role. And the next thing that becomes a role is an identity federation. So here we got my AWS cloud, and I have an enterprise. And in my data center, I've got a beautiful Active Directory server with all 200,000 employees. So I just connect that, my AWS account, to my Active Directory server, and then AWS inherits all those great things from my Active Directory server, and all of my IAM is done. Or better yet, you can connect to an identity provider. Connect to Google. Log in with your Gmail account, for example, a single sign-on. So once we get into that, we're talking about roles. So IAM users are people like me, like Cindy the cat, like Noni the cat, like Abigail, but a role would be when my server connects to another server, or if I log into my Active Directory server and then it comes back, it's also considered a role, not a user at that point. Keep that in the back of your mind. And IAM roles really enhance security, because here's the thing. If you've got a server and you've got another server and they need to talk to each other, what people used to do was put a password on the server, username and password on the server. Okay, so let's think about this. Got an application server with a password to the database server. You hack into the application server, guess what you hacked into? The database server. So no good. So we don't want to do that. So by doing this, by using a role, we don't need to store credentials on the sys server. So what happens, the AWS service is providing a temporary token. So system one wants to do something, so it goes and gets a token. The token is a one-time password that's effective for a period of time, and it can access the next system. And by doing that, we've got good security. And tokens expire. So got a token on this server connecting to this server. They're all happy. You hack into this server. The token expires 15 minutes later. What can you do on the server? Only 15 minutes, nothing longer. So that's why we're doing roles. So a role can be used for a system to access another system. A role can also be assumed by an application. So you've got an application, you need to do something. It assumes a role and then connects to another system. Now we're dealing with IAM roles versus users. We're using short-term credentials. And IAM roles leverage the AWS Security Token Service, otherwise known as STS. And these are temporary exposure. The default time to expire is 16 minutes. but you can set it all the way down to 15 minutes or 36 hours. So think about this. You've got a token that's good for 15 minutes. Somebody gets access to the token. The maximum time they can hurt you is 15 minutes. If they get access to that token in 14 minutes and it resets in 1 more minute, they have access to 1 minute. Now, if you change it to 36 hours, now somebody compromises your system on minute 1 of the 36 hours. They've got 35 more hours of damage they can do to you. So look at it this way. The more frequent the tokens, the less scalability, but the more security. The less frequent the tokens, the greater the scalability and the lower security. So the more often you do it, the less scalability, the greater security. So it's up to you. These are architecture things that the architects need to decide based upon the business requirements. Let's talk more about IAM roles. And while we're discussing IAM roles, let's have a little bit of fun with it. While we're discussing IAM roles, they're typically used to grant permissions for applications running on like virtual machines like an EC2 instance. IAM roles are used by people when connecting to external systems. IAM roles are pretty much used to grant permissions to an IAM user and the same account as the role, for example, and it's also used to grant permissions to IAM users in different accounts. So now you know a lot about roles. Let's talk about the AWS Security Token Service. So the AWS Security Token Service is really designed to provide trusted users with one-time security credentials. So, one-time passwords, things that expire. And you can specify the expiration level, as I mentioned, between 15 minutes and 36 hours, but the default is 1 hour. See, what happens is once these credentials expire, that's it. They're no longer recognized, and that's why we love them. So temporary credentials are dynamic, and they're going to be generated every time a user requests them. So let's briefly talk about cross-account roles. Now, cross-account roles are roles that enable you access into another AWS account. So Mike's cat Cindy's account, Abigail's cat Noni's account, they've both got little websites of the cats doing all kinds of cool cat stuff. So now that we know that, those are what we're dealing with in these particular situations, the Noni and Cindy. So, if Cindy wants to access Noni's thing, Cindy's going to need a cross-account role to get into Noni's virtual private cloud. And if Noni wants to get into Cindy's thing, she needs a cross-account role that's got access to the permissions that she needs to be able to do her job. So you can set up an access to an account that you don't know, for example. Here's some best practices when dealing with cross-account roles. Connecting to other organizations. Okay, that gets pretty scary. So, as soon as you've got connectivity, both your connectivity should limit access to things by who has access to what route and what resources. Systems should be firewalled off, etc., as appropriate. But also, guess what? We need to lock our systems down, because if Noni the cat wants to get into Cindy's the cat system, maybe Noni the cat's got some mischievous ideas. Maybe she wants to steal Cindy's food or Cindy's rat or a mouse or Cindy's birds or things. So, Cindy wants to invite her friend Noni into the house. And there's that. And actually, Chris right now has got a cat named Sunny, who's also a beautiful cat. So, now we want to give access to Chris's cat, Sunny, to the VPC. We've got another cross-account role. But see, Sunny the cat doesn't like other cats. So Sunny the cat, who's the most beautiful Maine Coon orange cat you've ever seen in your life, gets access to different positions than Noni the cat. And that way, everybody's happy. So whether you're dealing with cats, whether you're dealing with people, or you're dealing with companies, it's the same issue. Give access to what you need and nothing else. So let's look at some more cross-account role examples over here so I can show you what it looks like. If I can find this part of my computer screen, bear with me a little bit. Got too many windows open, too many monitors on my screen. So in this particular environment, here you can see you've got a company A, B, and C. And with the cross-account roles, they're being able to get into a single account and access information and things like that. And that's really why we love cross-account roles, because they enable you to connect to other systems that are already on the cloud, like in a VPC peering environment. So let's talk a little bit more about how it works over here. Basically, you create a role for the external user. Now, the external user, like Noni the cat, connects to the token service, the security token service, and gets a token. And then when Noni the cat wants to get into Cindy the cat's VPC, she provides her token. And Cindy the cat says, welcome, Noni. Now let's share our cat kibble together. And then the same thing happens with Sunny the cat. But that's what we're doing. We're creating accounts across systems that enable systems to talk to each other's systems. So now let's talk about service accounts or service roles. So normally speaking, an IAM role to connect to another system, I would call a service account, because I typically don't use AWS marketing made up terms. I typically use the industrial terms, and the industry has been calling this a service account for as many decades as I remember. So I call it a service account. But what is a service account? It's when you have access to one thing. So that's all we're talking about with an EC2 service role. We will need an EC2 role or an EC2 service role. For example, if we want an EC2 instance, like a virtual machine, to post message in an SQSQ, if we want to access something in an S3 bucket, if we want to access one of the AWS relational databases instead of creating our own database system, we are going to need access to an AWS service role. And here's what it looks like. We've got our system over here. As in blue, your virtual machine is your EC2 instance. And it wants to connect to this proprietary, awesome NoSQL database, DynamoDB. So what happens, the system has an EC2 role. It goes to the security token service. The security token service gives it a token, and then EC2 provides that token and gets access to DynamoDB, and it can write its things down. Okay, now we're going to get into the concept of identity federations. And that stuff gets pretty ugly, but we need to cover it, and it's very important. So let's do this. Let's open it up for about 5 minutes of questions, since I know we haven't gone on that long. Let's try to answer some questions and make sure that everybody's solid before we go on to the next question. I haven't been able to see what's been coming on in the chat box. Okay, so a federated user is different than an IAM user. Technically speaking, an IAM user is somebody in AWS. So here's what happens. I could, if I desired, create all my user accounts in AWS. I could do that. Could. But then I've got to do it here. Now, by comparison, Tata, if I connected my AWS environment to an Active Directory server that had all of this, for whatever reason, AWS says, if you authenticate to Active Directory and you come back, it becomes a role. So federated user is not exactly the same as an IAM user. And the difference is an IAM user is internal to AWS internal management system. And when we deal with what we're dealing with here, which is we're connecting to an identity provider, it becomes a role and not a user because it's external. So it's more like the Crossaccount role, even though it's not exactly a Crossaccount role because of those reasons. So, but the reality is they do the same thing. So I could set up a user group called Cloud Heroes Africa, which is a group that I'm very passionate about, and I know you're part of, and I work with, as well as my team, Chris Fernando, and so many wonderful people that you see on this call. So, there's that, and we could do that. And I could connect Cloud Heroes Africa, which is a group of people that I know and love so much, through directly to my Active Directory server that would have all my users. And what could happen, Tata, is you could connect to my Active Directory server, and then I could authenticate you for your own Cloud Heroes Africa program if I chose to. And that's what federated IAM is. So federated IAM is reaching out to an identity provider, Instagram, Google, Facebook, LinkedIn, or an Active Directory server. Great question there, Tata. So it is so AWS use Microsoft AD for IAM? AWS is their own company, so they make their own proprietary thing. Now for their internal users, I'm sure they're using Active Directory for their employees most likely. Now, I will say this, most enterprises use Microsoft AD and not the AWS function for it. They actually federated to it. Nearly all of them are going to use single sign-on. So for the most part, I don't know or have ever worked with anybody that would use AWS IAM, and here's the reason why. They're going to all federate with Active Directory. Who would use AWS IAM? My cat Cindy. She's making a website because she's only got a few people. Who would use the AWS IAM? Somebody that's got a small number of employees, nothing to worry about. Who uses Active Directory? Everybody, every enterprise. And why do they do it? Because it's easy to manage. So it's all about choosing the right tool for the right use case. Good question here, Philomena. How do you keep each user on a group accountable? Okay, so Philomena, tomorrow, I would like you to go to Coronado Island and walk onto a Navy SEAL base where they're doing training. Drive up to that front gate, and what are you going to see? A bunch of Marines or SEALs with machine guns, and you're not getting onto that camp. So IAM does the same thing. Who are you? Okay, you are Philomena. Now you're going to go try and log into the server. You're not allowed. You're just going to be blocked and denied. So it's kind of the same way as if you tried to walk into a private party and there were security guards at the door and you walked in the door and they'd say, out that door. That's exactly what's going to happen. You're going to log into something you're going to try and log into. Not only will you not be, you may have an alarm go off and they may even send security to you, depending upon how tight it's locked down. Liz, does federation imply inheritance of credential information from one system for another for authentication? Effectively, yes. Exactly. That's the whole point. Got your Active Directory on the server that says Sonny the cat can access this, and Sonny the cat's allowed to access that based upon the information in the Active Directory server. Exactly, Liz, and fantastic. Asim has. How is scalability affected by the token length time to live? Well, think about it this way. If you're sending a token every 2 minutes, you're placing work on the systems. If you're placing tokens every 2 days or every day and a half, it's less work. So always, the more frequent the updates, the lower the scalability. The less frequent the updates, the more scalability. The more frequent the updates, the more dynamic the environment is. The less frequent the updates, the more stable it is. It's up to you, based upon the business needs, Asim. Good question, though. Jonathan, tokens don't create any lag, so it's not relevant at all. If the token expires between the tasks, the system is not allowed in because the token will be rejected. So that's what happens if your hackers get access to your token. And that's why we're using these tokens, because once that token is expired, it is worthless. That's the whole reason. All users are technically principals in AWS, but the principal user or most effective user, that is the root user. Okay, so good news, we got through that because now we got to get into some ugliness. But before we do that, please vote on the next boot camp. Do you want it to be a Google Professional Cloud Architect, or do you want an AWS, or do you want an Azure Solution Architect course? I don't care. They're all the same. Cloud 1, Cloud 2, I work on them all. I just want you all happy. So, kind of do that. And also, before we go back to this, you can give me a hashtag cloud hired and a hashtag cloud architect. For me, it's why I wake up. It's why I live, while I breathe, and while I sleep, to get you all cloud hired. So you can give me a cloud hired and a cloud architect in the chat box. I'd be all kinds of happy. And if you want me to talk about Azure, we'll talk about Azure. I love Azure. You want me to talk about Google? We'll talk about Google. I love Google. We're cloud architects. We work on all clouds. I just want you getting cloud hired as a cloud architect, cloud engineer. And actually, instead of just doing cloud architect, if you want to be a cloud engineer, type hashtag cloud engineer. You want to be an architect, type hashtag cloud architect. You want to be a Linux engineer, type hashtag Linux engineer. Let us know the goal of your dreams, and we're going to get you there. We know your career, we'll get you there. Get you cloud hired, cloud promoted. So vote on our news boot camp. Give me some of these things that make me happy. If you don't mind liking, commenting, subscribing, telling others, telling friends. That's why we do what we do. So we just want to get you your goals. However we do that is totally fine. I don't care. I just want you all cloud hired. So let's get back to the content over here. So now we're getting into some deep weeds here for a few minutes. And we're going to talk about identity federations. Apologies, it's a little ugly, but it's great stuff. So identity federations allow management of identities in a single place, aka Microsoft Active Directory. Beautiful system. What are the key components of an identity federation? Let me tell you right now. an identity or a user. So a user, an identity store, where you store your identities like Microsoft AD or Facebook, etc. Next, an identity broker. We need an identity broker. What's that? That's going to be an application that's going to check the identity store and provide temporary tokens. So what do we need? A user, an identity store where the information is stored, and a broker that's going to do the checking. So now you know. Now here, this is the ugliest workflow, but I'm going to talk you through it just so you know. Step one, the user is going to log into the identity broker using their corporate credentials. That'll then happen is the identity provider is going to authenticate the user against like an LDAP-based identity store, for example. And then what'll happen is your identity provider is going to generate a SAML, security association markup language token. It's the 2.0 version of what we're talking with. And it's going to have all the required information. It's going to submit this security assertion to the identity broker. And then what'll happen is the identity broker is next going to come up with this kind of called the SUME role with SAML, and it's going to basically use the security token service API, and it's going to push the SAML assertion and the role to the resource name. And then what's going to happen is, assuming everything works and the API responds and it's successful, the AWS is going to provide like the temporary token and credentials. And then when the temporary credentials are there, the client will perform the operation and access. So it's really an ugly process where the user's got to log into the identity broker, the identity provider then authenticates it, then a token is there. It sounds kind of complicated, but that's exactly what you're doing. So next, with regards to these federations, why are we using them? Well, it's really just about enhancing scalability, because do you really think with a company with 300,000 users, you're going to just enter a username and password, and permissions for everybody? Of course not. It'd be insane. So we're doing this to increase scalability. And what's going on was we're establishing a trust relationship between our AWS account and the identity provider. And realistically speaking, we've got two ways we can connect to the identity provider. We can use something called OpenID Connect or SAML 2.0, which is what we're going to use. Let's not making things complicated. Now, who are these identity providers we can connect to? Google is one. Amazon's another big one. Facebook's one. Twitter's one. LinkedIn. And we're just pulling the information off of that. So let's try to give you a little bit more on this. AWS IAM functions are connected based upon the identity provider, and that's what we're doing. User is going to request authentication, and it'll be passed from AWS to the identity provider. The identity provider will provide the right information, and the users will get access. Now you understand. And this is going to be the way you're going to deal it for 90% of all global enterprises. Now, as we're dealing with all these identities and sign-ons, we're starting to deal with users and user complexities. So in a really secure environment, I worked in one. You log into one system. A minute later, you log into another system. A minute later, you log into another system. A minute later, you log into another system. And I remember on some days logging into 20 different systems to be able to do my job. Now, I want you to think about that. If I have to remember 20 different passwords every single day of the week, and I'm not allowed to use a password called Cindy, like a cat, and my passwords are all 18 characters, they include special characters, numbers, letters, etc. That's what's reality in today's world. 30-character passwords with crazy numbers. So if I'm dealing with that, how do I remember my 20 passwords? I don't. So you know what I do? I take sticky notes with passwords and I put them on my desk so I can see them and remind myself. And everybody that passes my desk, you know what they do? They know access to all my usernames and passwords. So because of this, because in a high security environment, we go so cuckoo that we teach our people how to create ways to break through our security. That's what we're typically doing. So, kind of keep that in the back of your mind. So what's the solution to this? Well, single sign-on. If we come up with a single sign-on solution, guess what? Our users won't be so angry at us. They're not going to do crazy things to work around our system. So single sign-in is an authentication method. Lets you authenticate once and then be authenticated to multiple systems at the same time. So AWS has a single sign-on service that allows you to sign in one place and access your resources everywhere. Single sign-on is usually used in a federated environment. Single sign-on is beautiful. It's going to integrate with Microsoft Active Directory, Azure Active Directory, Salesforce, or other main directory services. It enables your users to authenticate to the identity provider, and then they don't need any more logins to get anything else. And that we're super, super excited about. So when the user signs in, they're authenticated against an identity provider. Their group will be determined, their privilege will be. And I love federated access, identity federation, single sign-on. For those reasons, it keeps your user from doing crazy things to get past your crazy security. So basically speaking, we've got our nice on-premise Active Directory server, which we federate or connect to the AWS service. And now we log on to our Active Directory server, and we access our object storage bucket, S3, our proprietary NoSQL database, DynamoDB, should we be using it, or our virtual machines, otherwise known as our EC2 instance. And that's going to work, and it's going to be perfect. Now, understand a lot of this IAM stuff that we're covering now is more for the certified solution architect professional. But here's the thing. It's information you need to know for your job. So we will never deliver a course that's based upon delivering the minimum for certification. Everything we do is based upon giving you skills that are marketable, valuable skills. So understand I'm going a little deeper than you need to know here from an architecture perspective. Let's talk about another way to do identity federations. And we're talking about Amazon Cognito here. And what is Amazon Cognito? It's going to be a service that's going to provide authentication, authorization, and user management for web and mobile apps. Okay. It's a means to connect your apps to identity providers, and Cognito enables organizations to synchronize their identity management and data across multiple devices, which we love. So, we're kind of in one of these positions. So Cognito users can sign in directly with a username or password with a third-party identity, such as Facebook or Google. How's it going to work? You got a user, they authenticate against the Cognito app, then they get a token, and they use the token for access to the AWS resources. Nothing overly complicated. So it's going to look like something like this. Got your user. They authenticate to the system. They get tokens, and the token gives them one-time password. So it's super secure. So when we're dealing with one single sign-on, we're dealing with one-time passwords. They're tokens. So if anybody compromises the password, guess what? It doesn't matter because they can't use it again. So that's how we're making these single sign-on and federation things work intelligently. So when we're dealing with Cognito, we're dealing with the concept of user pools and identity pools. Here's a user pool. It's a secure directory within Cognito that enables you to manage your users. That's all it is. And upon successful authentication with Cognito, a set of temporary tokens are typically a JSON web tokenization. Now we'll also talk about identity federations, Amazon Cognito identity pools. Amazon Cognito identity pools provide temporary AWS credentials. Cognito identity pools work with authenticated and unauthenticated users, so we can deal with guests or authenticated users via token. Now, how does this Cognito user pool work? Well, it's kind of ugly just like anything else, so we'll describe it in its ugliness. We got the user, they log into the identity provider. You log in, and guess what? You get authenticated, and you get a session key for the user. Then the user basically uses the session key, and what's going to happen is the application will call an API, most specifically the Amazon Cognito Get ID API, and it's going to get an identifier for the user. And then what will happen is Cognito will validate the session key from the identity provider. And if the session key is valid, what will happen is the API will get kicked in. The Get ID API will return an identifier back to the user. The user will send that unique identity back to Cognito. Cognito will validate their session token against the identity provider. And assuming it's valid, they'll get a token, an STS token. And then Cognito returns the token to the application so the application or the user can access services. So that's how Cognito works. Let's briefly talk about the AWS directory service. Now, normally I said we use Windows Active Directory servers, right? Well, if you don't have your own directory servers, AWS gives you the option to basically make a directory service. Now, guess what? Here's how you could do this. You could just set up a virtual machine and make it your own Active Directory service, or you can use AWS Directory Service. And what do you think AWS Directory Service is? Nothing more than high availability Windows Active Directory servers that are fully managed for you. So in either case, you're still using Active Directory. This is a more inclined to the Azure AD that you would get an AD where you're getting Active Directory servers that are part of Azure. Well, the AWS Directory Service is Microsoft Active Directory servers hosted by AWS on the AWS cloud. So if organizations have Microsoft dependent workloads, need Microsoft authentication, they have the AWS Directory Service. Okay, so now when it comes to the authentication, we got a couple of options. So how do you want to log in? Well, there's a couple ways, and each way has its strengths and weaknesses. Let's talk about the least secure way. Username and password. Username Cat, password Cindy. Clearly not optimal. So there's very few things that I have in life that only have a password, and if I do, they're going to be like 60 characters long, because that's the only way you can do it in today's world. So username and password, log in, get a password. But that's not greatest. Now, what if you want to get a little better? Well, we can use an access key. An access key is a combination of a 20-character key ID and a 40-character secret set. Wahoo! That's going to be used to connect to the API. That's secure because you got 60 characters. Woohoo! When it really matters, you can actually use an access key and a session token. I'm loving this. So here's what goes on here. When the IAM authentication needs to occur under an assume role, a token can be provided, and the token is given alongside the access key. So now you've got your 20-character key ID and your 40-character key secret jet and a token at the same time. Now nobody's breaking into you that easily. So this is what we love. So now you know those we can use for authentication. Let's talk authorization. Authorization is what are you allowed to do? So authentication, let's go back to the cat and the people. Abigail comes to my cat. She knocks on my door. I give her keys to the house and the car and say, go wherever you want. She's authorized. Chris comes to my house. I do the same thing. Leo comes to my house. I do the same thing. Now Joey knocks on my front door, but I don't know who Joey is. So I say, you stay there. Identify yourself as I look through the window. Provide an identification. Hold on, Joey, while I do a criminal background check on you. Oh, wait, you have a criminal background check? Came up positive? You're not allowed in. Go away. Or you have one in and I'll remediate you. I don't care, whatever the case is. That's authorization. So what's going to happen is we're going to write an identity and access management policy. And, well, I'm not going to say we will. We will come up with the architecture, security architects, and the cloud engineers will be writing this policy. Or your security people, and they're going to be writing the policy in JavaScript, object identification, JSON format. So you want to see what it's going to look like? I'll show you. Basically speaking is you're going to create a policy, and there's going to be an effect, which is basically, do you want to allow it or deny it? And then you're going to have to tell it, what are you allowing or denied, which is the service. And then you're going to identify the resource by an Amazon Flow resource name, which these are these ugly names like the ARN colon AWS IAM, and you've got something. So that's what you're dealing with. And then in there's going to be an action. What do you want to happen? And of course, you can add some conditional attributes if you desire. So think about it this way. What are you allowed to do? What service are you giving access to? What's the exact resource? So this gets you pretty darn granular. Goes back to the same thing, authorization. I want to go to S3. Guess what I'm allowed? Now I want to go to the management console. Nope, not allowed. Block, block, block. Why? Because I don't have the need to go there. I am not authorized. So it's like showing up on a military base without the identification. You're not getting in. So let's talk a little bit about creating some IAM policies, and then we'll take a break for some questions. So with regards to creation of policies, there's a couple ways you can do it. What is the policy? It just says who does what. So there's a few ways you can do this. Well, you can take a managed policy from AWS, which I love, or you can make your own. So let's now think about this. AWS does have some extremely well-made IAM policies. Guess who else does? Microsoft with Active Directory. And these are common use cases. An administrator, a power user. And generally speaking, what's the difference between a power user and an administrator? Administrators can create user accounts, and generally power users can do everything other than that. So keep it down. So that'll be an example. So when you're dealing with AWS, there'll be managed policies. Policy for this role, this role, this role, this role, this role, and this role. And you know what? These are good policies for the average enterprise. Just like all cloud services, this is for the average enterprise. So if you need to use one of those, you can take an AWS managed policy, and I'm going to tell you in like 95% of use cases, it's going to be perfect. But what if it's not? What if it's not perfect? What if you want to do something different? Guess what? No big deal. So good. Let's look at this. So here's what we then do. So we can create our own. We could write our own policy any way we want if we need something custom. So let's talk a little more about IAM policies. We can get standalone policies created by AWS. Permissions for most use cases designed by people that know how to do it. Common use cases. Based on job role, they have basically two major identifiers: administrators who can do anything, and power users who can do anything but don't get access to IAM organizations. That's just one. But we can make it whatever we want if we need different. We can create a managed policy, and there's a couple ways to do it. We can sign into the IAM console with administrator privileges, and the navigation page, choose the managed policy, simple to use, and it is nothing. How about a customer managed policy? Well, we got to create our own. So how do you do this? Well, a couple of ways. We can take one of those AWS managed policies. We can tweak it, and now it's our own. So we can copy one and start. And if you're not a great JSON programmer, this is what I recommend you do. Or there's the policy generator. And I'll show you what the policy generator looks like in a second. You can go to this page called the policy generator. And for the most part, it's going to ask you a bunch of questions. What kind of policy this? And it's going to automate something for you. And, it's basically going to work. Or you can create one from scratch. What do you mean create one from scratch? If you've got good JSON programming skills and you know the proper grammar and syntax, just make it yourself. And, if that's your key, create it yourself. Tell me what you want to allow or deny, and what resources and what conditions, and you'll be done with it. And that's totally, totally appropriate. But you've got to have some coding skills to do that. So keep that in the back of your mind. So we're going to get through the IAM stuff, and then we're going to get into, and we're done that, we're actually going to talk about security, which I'm looking forward to, because I don't consider IAM security. It's another career. So now you know what we're talking about here. We can create our own. Obviously, they look like something like that. Now, how else can we further secure stuff? Multi-factor authentication. So I go out there to Abigail. She comes over to my house with Noni the cat. Noni the cat's beautiful. Looks a lot like my cat. They'd be great friends. She's knocking on the door, right? And I'm not home. So what if, for example, I've got a security camera, and the security camera sends her a challenge? You look like Abigail, but I'm not sure. Could you provide your temporary authentication token? And then Abigail's given the temporary authentication token. And guess what? The door opens up automatically for her. Cindy the cat comes and rubs over to her feet, says hello. Cindy the cat then walks Noni the cat to her tuna bowl and her shrimp bowl and her scallops bowl, and the two of them have a party together. Multi-factor authentication. Let's face it, multi-factor authentication is really critical in today's world. You sign on in the management console, you get a challenge, which is a one-time password. You provide the one-time password. Bob's your uncle. You get access to this system, and everything is just beautiful, beautiful, beautiful. So we've spent an hour and 20 minutes in what's most likely the ugliest content in the entire week. So, woohoo, we kind of covered that. Let's ask some questions. Let's make sure everybody's up, and then we're going to get to the fun stuff. A seam. Although SSO alleviates the need to use multiple names, doesn't it become easier for a hacker with one credential? Well, it would be a seam, but what's going on here is we're going to be using temporary credentials that are going to expire, and that's how we're going to get to the same level of security. And here's the secret, dirty little secret of security. When you make security too complicated, your users find ways to create backdoors. And I got to tell you, in my 25 year careers, I have seen more password sticky notes on people's desktops. I have seen people that have gone to extremes to violate the security when it's too tight. So it's about using the right security that is minimally intrusive to the user that provides the maximum protection. That's what's the key to the architecture to make it work. Cognito is generally used for mobile devices. Great question there, Cal. LM, absolutely multi-factor authentication could be compromised. Look, here's the thing. Identity and access management is not primary security. It's your last line of defense. Your primary security is covered by your IDS, IPS, your firewalls, your IDS, IPS systems, your access lists, your security groups, your host-based firewalls, your endpoint protection. That's your security. Multi-factor authentication, and by the time we're using it, it's too late. I'm already knocking on your door. Here, I'm here to attack you. That's what IAM has. All the other stuff that I'm talking about keep people from getting to the door in the first place. So the key is, we want to get it. We want some real security. IAM is just a small component of security. Now, Phil, this is so critical that I will tell you there are hacks every single day on the AWS cloud, and most of them are related to misconfigured S3 buckets. Now, I know some people in Israel that find a new vulnerability and how they can hack into AWS or Azure every day of the week. They can, but 16% of all cloud hacking attempts that occur are due to misconfigured S3 buckets. And that's the biggest problem we're dealing with. Christian, go to the next one. Danica, thanks so much. You clicked the like button so much time. You don't have the like button doesn't have a thumb anymore. Thank you so much. And while we're at it, if any of you are here and you have a good time, if you can like, comment, or subscribe, it signals the algorithms that we're doing is good work to help other people in the world. And it will show this free training to more people so they can build their best careers. So please give us some likes, comments, and shares. Make a post about it. Tell your friends. It's all free. We just want to help people. And thank you so much, Danica. Are there default policies defined to every? Well, you determine what you're going to assign to every user. You determine that. And if you don't, anything that happens to automatic or default is never good enough for anything. So you make those determinations. Chris, you can go to the next one. You're more than welcome, Asin, and thank you so much for participating. Okay, well, now we get out of that IAM ugly stuff and we get into some security stuff. And maybe if you guys desire, we'll teach you how to put it together in the end of the class. So the next thing we're going to talk about, which is one of my favorite things in the world, are firewalls. What is a firewall? So when it comes to enterprise security or security in general, there's a lot of tools that we can do, but the firewall keeps unwanted traffic out of our systems. I like to view a firewall as like, let's say we had a castle and we had a 100-meter wall around the castle. And it's this big giant wall that makes it hard to get over. That's the firewall. Here's what firewalls do. They allow our outbound traffic out to the internet and they allow our return traffic in and they block all traffic. So firewalls are used for perimeter protection. They filter traffic, they are stateful, and they watch what's going on. By the way, modern firewalls, real firewalls, the kind that you should be using in your architectures, the kind that are designed by, Cisco, Palo Alto, and Fortinet, those firewalls are adaptive in nature in that, let's say you've got this firewall, which is the equivalent of a 300-foot wall around your building. And let's say on top of this 300-foot wall, you took some British SAS commandos and you took some Navy SEALs, and you took some Israeli commandos, and you stuck them all on top of that 300-foot wall and gave them sniper rifles. That's the equivalent of an intrusion detection, intrusion prevention system. And modern firewalls will do that. They'll block all the attacks. And if an attack happens, it's like having a bunch of SEALs on top of the firewall that to stop the attack in real time by resetting TCP connections, etc. That is a next generation firewall, and that is what you should be using to secure your systems. Okay, now we're going to talk about the AWS firewall, which doesn't do any of that good stuff, but it's the one that's on your certification exam. So we will tell you this for the certification exam, and then before we end the day, we will teach you how to secure your systems the right way, the way your customers will expect. But this is a certification course, so we've got to teach you some of the certification things. So the thing that we're going to talk about next is AWS WAF, which is a web application firewall that monitors for common routine exploits. And basically it monitors HTTP and HTTP requests, and that's it. And it looks for exploits. And you can put it on a CloudFront distribution, an API gateway, a REST API, or a load balancer. And basically what happens is WAF will block connections at the edge locations or edge place before they get on your network. And it can control access to content that users specify. But remember, this is an AWS proprietary managed firewall, which means if you're going to go multi-cloud, you don't want to use this because you're going to have the same firewall policies on multiple clouds. So this is something that we need to talk about. WAF is the AWS Cloud Native Firewall in the AWS environment. If you are protecting my cat Cindy's website, this is a beautiful, beautiful service. If you're dealing with global enterprise customers, they will expect a firewall from the marketplace, a Palo Alto one, a Cisco one, a Fortinet one, a Checkpoint one, something major and industrial grade. So kind of keep that in the back. But while we're talking about WAF, how does it work? Basically, you enable it on the application or device. You create a policy of filter this versus filter this. The WAF will analyze the traffic based upon policy, and it'll either permit it or deny it. And if a new attack occurs, guess what? You create some new rules to stop it. And it can integrate to CloudWatch to give you some system information. But remember, this is an AWS firewall, and enterprises typically use more robust solutions. So here's what it would look like with AWS. You basically, assuming you're using their stuff, you basically put your WAF on CloudFront, your load balancers, and your gateways, you set some policy, and that's it. It's a basic thing. Now, I've never used WAF in an architecture because I use enterprise-grade firewalls and IDS, IPS systems, but understand this is the AWS Cloud Native way to do it, and this is what's going to be on your security certificate. This is what's going to be on your AWS certification, so understand WAF is the AWS firewall. So what does it look like more holistically? Well, it's really going to look like this. It's really going to look like you're going to have your internet gateway. On your load balancer, you're going to place a minimum, what do you call it? A firewall, and that's going to be then backed up by a network ACL, a security group, and hopefully you're doing something on the security instances, and that'll provide generic fine protection. It really will. There's nothing wrong with this architecture if you're using a single cloud. But if you're using multi-clouds, we can't be using proprietary firewalls that all don't work the same. We have to use the same kind of firewall in all environments. And since everything is multi-cloud, this isn't going to be a common architecture you're going to be deploying in anything other than an exam. So next, let's talk about distributed denial of service attacks. And how do we deal with them? So first, what is a distributed denial of service attack? And here's what it looks like. Let's say we got a bad guy or girl over here. We call him attacker. The attacker has a server. Now, the attacker gets really smart, and the attacker says, compromise all these servers. And what happens, the attacker creates an army of infected servers. And then the attacker launches this army of infected servers on a single system. So imagine this. Let's say we've got it where it says web application. Let's say this is a beautiful web server, and it can serve 5,000 requests per minute. And it's doing great. But here, the attacker decides to launch 100,000 requests per second on a server that can handle 5,000. So what happens as follows. Request. The server gets busy responding to requests. The server can't meet the needs, and the server crashes. Or the server doesn't respond. Or the attacker fills up a buffer flow and then can compromise the server. But this is bad. So what's going on? What is distributed attack? Denial of service attack? It's when you use systems on the internet to overwhelm a system or a service. So how do you prevent it? Well, a lot of ways. Let's talk about how do you do it. Well, first, if the firewall blocks all unwanted traffic getting into your systems, you're not getting a DDoS attack. Now, we're typically going to use a content delivery network. And we'll talk about CloudFront. We get into content delivery networks. And on the content delivery network, we can put some DDoS protection. And why do we love the DDoS protection on content delivery networks? Here's why. You get a request. It goes to the content delivery network for the web server. The content delivery network looks at that request and says, bad request, don't even send it. So just by doing that, we get 100,000 requests per minute for a web page that's bad. The content delivery network drops it all. So at the content delivery network, we drop it all. Then at the edge of our network, guess what? We put a firewall. The firewall blocks all incoming traffic. Then with a modern firewall, guess what we do? We have an intrusion detection, intrusion prevention system. And what's the cool stuff about this? It's like having Navy SEALs that are out there that are getting rid of anybody that bypassed the content delivery network, that then bypassed the firewall. Now we've got the IDS IPS system. So you can see this as labels. And then we keep traffic out of the subnet with an access list. We're then going to keep traffic out of the server with the security group. You see what it's layers here. Then on the servers themselves aren't hardened. We're going to put another firewall on that server, like a host-based firewall, a host-based IDS, IDAPS, intrusion detection prevention on there. We're going to disable unnecessary services, close down IP ports. We're going to put some anti-malware protection on the server. And I mean, we're going to have to harden the server as well. So, there's that. Maybe we encrypt the storage on the server. So you can see this is what goes into preventing DDoS attacks. Now, adding a DDoS prevention service on the content delivery network is excellent, and we strongly recommend it. If you use CloudFront, we've got a content delivery we've got a DDoS service called Shield. If you're using Akamai's content delivery network, guess what? They have their own. If you're using Azure's, they have their own. You're using Google's content delivery network, they have their own. You're using Cloudflare's content delivery network, they also have their own DDoS protection. Here's what it is. They don't send illegitimate requests to the web servers. Now, AWS does have some very good DDoS protection. It's excellent. Their Shield and Advanced Shield are very good. And they really do belong in a good security architecture. Production, non-production, it's excellent. CloudFront is a strong, solid, robust content delivery network. And the DDoS protection on it is excellent. There are two versions, AWS Shield. Shield Standard, Shield Advanced. Excellent and real relevant in today's world. So those are the things that make me excited when it's actually relevant. So how does it work? Shield Standard comes free when you're using the AWS firewall, if you're using that. So you might want to stick your firewall on the CDN and Shield, and then use a real firewall to protect your enterprise, like those from the marketplace, something from like Cisco or etc. But Shield protects against common DDoS attacks. According to AWS, they say 96%. I wouldn't believe it. Vendors always have really exciting rates, which look good on paper until the attacks change. So they say 96%. Whatever the point is, it's relatively good. Shield Standard protects against SYN, SYN attacks, reflection attacks, HTTP slow read attacks. So your main ones. But it blocks based upon policy. So whatever you configured is there. Now let's talk about Shield Advanced. Now there's where we're starting to get to something. So Shield Advanced is not free. It's a couple $1,000s a month, and it provides protection for load balancers, virtual machines, CloudFront, Route 53. And here's where you're starting to get into some intelligent attack mitigation. So it's adaptive in nature. It looks for patterns of behavior that are not normal, and it thwarts them. Again, If you bought a firewall from Palo Alto, it would do all of this automatically. But, as far as AWS using Shield, it gets adaptive when you start using services such as Shield Advanced. And Shield Advanced basically will deploy ACLs or whatever it needs to do, and it's looking for layer 3, 4, and 7 attacks. And if you actually spend the money for Shield Advanced, you've got a 24 hours a day, 7 days a week DDoS response team, assuming the customer is on business or enterprise support. So now you know about Shield. Now, we're going to talk about some AWS security services. And, well, we'll just talk about them. The next service we're going to talk about is GuardDuty. GuardDuty is an automated service to monitor your AWS accounts. It'll analyze your CloudTrail logs, DNS, VPC flow logs. And here's the thing. It's going to look for patterns of behavior, and it'll send you messages to say if it sees things it doesn't like. Now, here's the key. If you were using a next-generation firewall, you would already know that and not need this. So if you're getting an industrial-grade firewall from the marketplace solution, things like GuardDuty become not that important because you're already going to get this information from your security devices. Let's talk about the next Amazon security thing. So this is Amazon Inspector. And this is an automated security service that helps improve the security and compliance deployed in your systems. It effectively assesses your applications for exposure, deviations from best practices, and after performing an assessment, guess what? It sends you a detailed list. But automated assessment, which means take the results with a grain of salt. Half are going to be great, half are going to be garbage, because automated is never good enough. But automated gives you something, so it's a start. Next, we'll talk about Amazon Macy, which is a fully managed data service and data privacy service. And what's going on here is it's using machine learning and pattern matching heuristics to protect your sensitive data. And what it's going to do is provide an inventory of your S3 buckets, encrypted, unencrypted, and then it'll put a machine learning algorithm to help you make the difference. So, two last components we'll talk about in security. We will talk about the service catalog and the systems manager parameter store. So what is the service catalog? And it's a great idea. The service catalog is this. Many years ago, when I was a little network engineer code before I became a network architect, I remember the systems were slow. So I ran around with the protocol analyzer, which we used to call a sniffer. I'd stick the sniffer on the network and I would see, okay, this user's going to this illicit website, downloading inappropriate photos. This user's downloading music. This user put in this server. This user put in a video game server in their desktop. Pokes the hole from the firewall. This user did this. And as you can see, you've got some problems going on here. You've got systems on your network that become not secure, and they're attack vectors. So AWS has something called the service catalog, and it's a beautiful arrangement. It basically lets you control what your people put on the systems. But it enables you to create a list of approved services, machine images, servers, software, database, application architectures. And then when your systems admins, your cloud admins want to go build something, they go to the service catalog and they choose from the things that they're allowed to have. How cool is that? Choose from the menu of what you're allowed and nothing else. So how does it work? Well, you've got a user. They put their information in a service catalog, and you come up with an infrastructure as code script to launch it. Personally, infrastructure code should be Terraform, never AWS CloudFormation, and here's the reason why. There's no point in anybody learning an AWS proprietary service when, guess what? Everybody else is using Terraform, which works on all clouds. And since only 87% of people are multi-cloud, CloudFormation is a waste of your time. Don't learn it. Learn Terraform instead. So kind of keep that in the back of your mind. And the people that need to learn Terraform are the cloud engineers and the DevOps engineers, not cloud architects, because we don't configure. But different careers, and we all need different skills. So going with the systems manager parameter store, which is the next thing, what is this? It's a place to secure your secure stuff. So what do I mean by that? If this information is compromised, it can have some massive security consequences. So kind of keep that in the back of your mind. So the systems manager parameter store is a really great environment. And what does it enable you to do? It enables you to store secret stuff, database strings, passwords, etc. So kind of keep that in the back of your mind. So what we'll do here is, for extremely sensitive information, you want to encrypt your data, etc., etc., etc. So this stuff's going to separate the code from the password. So it's going to give you a means to track your audit access, etc., etc. So here's what we're going to do. Does everybody see how all these pieces and parts fit together? Do you need me to walk you through a demo for about 15 minutes of how we put systems together and how we make them secure? Do you need that? If you do, let me know in the chat box. If not, I'm going to keep going straight with the certification training. So what I'm going to do is follows. Excuse me for the coughing, it's making me tear. I'm going to do about 10 minutes of questions, then I'm going to do 15 minutes on showing you how the pieces and parts tie together, and then we'll get back to the content. So first, let's ask the questions, answer questions, and then I'll walk you through it, and then we'll get on to the next topic, which is AWS applications and services, which is a pretty extensive section at that. From a certification point of view, do we need to know how to configure policies, roles, cognito, or just know their usage? So I'll tell you one thing. If you knew the content, you could never configure anything, walk in and pass the certification exam like nothing if you knew the concepts. Now, you will get a couple of extra questions right if you do know how to configure things, but you're not going to be doing roles or cognito, I can tell you that, in any kind of certified solution architect associate, because most of that stuff is things from the certified solution architect professional that I included just to make sure you would know. Remember, on-premise identity access provider leads to AWS single sign-on. Now you're a granted system you're allowed to work on. Are you understanding the federated? Yes. If you're using federated with systems ID, log into that Active Directory server, get a temporary token, and go access all your systems with that temporary token. Absolutely. You can share IAM users with other organizations, and then it becomes a federated identity or a cross-account role, etc., etc. Absolutely. WAF is kind of like a layer 7 kind of thing. So it's typically layer 7. How does a CDN required if it's a common request? Doesn't it look like any other valid request? It's very easy. When you get a half-open SYN or an incomplete request, it's very easy to look at the patterns of behavior on the CDN. That's why I can describe it. When we talk about these things, we're talking about patterns of behavior. So, Kalpsani, I'll give you my life. It's Friday. Let's pretend it was Monday, and let's just say I was still working at Cisco as an architect. I'd go give a speech in DC. I'd go to California, give a speech. Then the next day, I'd go to England, give a speech. Go to Dubai the next day. Stop in Bangalore. Spend the weekend, because I want to go to Mysore and practice some Ashtanga yoga. Spend the weekend in Mysore, then go fly from India to Sydney. Spend a day or two giving presentations in Australia, etc., etc. Then go to Brisbane. Then go to Melbourne. Then go stop at Cairo. Then go to Cape Town, and then go back to Palm Beach. That's kind of the way my life would be. So, Kalpsoni, when I go do this, my credit card company just lets me do it. Now, if you tried to do that, and you didn't have a job like I had, where you're going from country to country and place to place, you'd leave your house wherever you're at, you'd go to your first place, you'd buy something, and you might get a call from your credit card company, wait, did you mean to do this? So what happens is the credit card companies are trained to look for patterns of behavior. It's called heuristics. And our intrusion detection and intrusion prevention systems, they look for patterns of things that look right, because no, these don't look like regular requests. There's something different about the request. And we're getting a lot of things that look abnormal. It stopped it. Just like when you would try and go to 3 countries in a week, chances are your credit card company would call you and say, did you mean to do this? Same kind of thing. Great question there, Kalpsani. You're going to be a great architect. Is it possible to use next generation firewalls? Yes, and we all do. None of us use WAF unless it doesn't matter. We all use industrial grade firewalls. Where do we get them? From the AWS Marketplace, from the Azure Marketplace, from the Google Marketplace, from the Oracle Marketplace. Guess what? If we got two clouds, can't have one firewall here and another firewall with different policies. That's not going to work. We go to get the same next generation firewalls from the marketplace, the AWS Marketplace, the Azure Marketplace, and they run on virtual machines. We use network load balancers to do that, and I'll show you how to do it in a few minutes. Great question. How is DDoS prevented? Well, lots of ways. You got a million requests coming from a million systems. If you drop all million requests to the content delivery network, there's nothing there. Then if they try to get through the firewall and they can't, they're blocked over there. Now, hopefully you've got an access control list protecting the subnet so it can't get through. Hopefully you then have a security group so that it can't go through. Now, hopefully your server has an IDS IPS system and a firewall on it, and it's been locked down. So if you bypass all of those, you still can't do anything. And then up and running, how about auto scaling? Ooh, auto scaling is great here. So we block everything at the content delivery network, but some gets through. We block 98% of it at the firewall, but 2% gets through. Our IDS IPS system blocks the rest of it, but 1% gets through. Then our network access control list blocks another 99% of the attacks. The security book blocks another 90%. And whatever is left over from that now hit the server, and it has a host-based firewall, and it has an IDS IPS system, which stops the rest of it. And then if something gets past and they overwhelm that, then this system adds capacity by adding 30 servers. And at some point, if you set your growth and your servers right in your auto-scaling group, you'll auto-scale beyond the servers that are attacking you. That's how we prevent DDoS. Well, every user is a privileged user. They have a user. The question is what you give them, what privileges they have. Zscaler is an extremely good solution. It is an end-to-end solution that it's a web application firewall, but it's next generation. It's adaptive. They got your intrusion detection. It is a real end-to-end enterprise-grade security solution. It's fantastic. It provides exactly what I'm going to show you how to do next in a new, more innovative way to do that. Federated identity and SSO the same thing? No. Federated identity management is as follows. I connect to an external provider and I get access to the system. Single sign-on is sign on once and get access to everything. Now, Sony, in most cases, we do single sign-on and identity federations at the same time, but they're different. Great question. Okay, so let's play with this for about 10 minutes. I'm going to walk you through, how the pieces and parts work together, because I'm teaching all these AWS services, and then the reality is I probably use none of them except for a few. So I want you to at least understand what we're talking about. So let's take this particular environment. The way we protect our systems is with a firewall at the perimeter of our network. So let's say we wanted to get we wanted a firewall. Well, in the data center, our firewalls are high availability devices. They're physical devices. We plug them in. We can run two next to each other. They can run a heartbeat, and we can determine which is the winner. In the cloud, are you allowed to go into the cloud data center, rack up your firewalls, zip, 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 then plug them in and cable them up? Of course you can. So in the cloud, when we go to the AWS Marketplace, the Azure Marketplace, the Google Marketplace, the Oracle Marketplace, we get a virtual machine with firewall software. So here's typically what it's going to look like. Now, there's a rule when it comes to availability and performance. The rule is 2 is 1 and 1 is none. So we need more than one firewall. So what do? We take 2 firewalls. So let's say we go to the AWS Marketplace and we buy 2 Palo Alto next generation firewalls. Okay. Now, how do we manage the availability? Like if one of the firewalls goes bad, we use a network load balancer. Oh, it works. Now we've got firewalls that are next generation. Now that should stop and be adaptive in nature. But you know what? Not me. I'm paranoid. So even though I've got some intrusion detection, intrusion prevention here, I'm going to do even more. I'm going to use another network load balancer, and I'm going to use a second set of IDS IPS systems. Why? because maybe a different intrusion detection, intrusion prevention system catches some things that the Palo Alto system or the Cisco one didn't do. Okay, so now I'm dealing with an industry-grade next-generation firewall, the way you would secure something that matters. And I've even got a second set of IPS systems to block attacks when they occur. Now, that's not security still. Let's say I have an access control list that protects the subnet. Now, you're talking about AWS, or we'll call it a network ACO, but it's just an ACO, the kind that Cisco's had for 30 years. Then we'll put a security group over here, which is going to protect the server. Now, that's not enough. On the server, we should probably put a host-based firewall, an extra one. We should probably put some host-based IPS. Now, have you guys ever done a netstat on your computer and you notice your computer is listening on like 18 million ports? Guess what? You got to disable all those unnecessary ports. So we'll just call it, say, harden. Disable unnecessary ports, patch, all that stuff has to go on here. This is the intro to security. This is an intro to junior level security. This is minimum security knowledge to work as an architect. So, and guess what? As a cloud engineer, you should know this is what it is too. It should scare you if all you see is WAF and Shield. It would terrify me. Now, it's not that WAF and Shield aren't good, but now think about this. How do you have two clouds and run a security policy secured by AWS native stuff its own way, and then do the Google Cloud Armor thing its own way, and they're both different in the way they work? It's a disaster. But you can go to Checkpoint, Cisco, Palo Alto, Fortinet, get the same firewall with the more features, more robust security, and it works in all clouds. Ding, ding, ding. That is your solution, and this is how you design it. And that's why it's so much different than we'd be talking about if we were talking about, for example, the cloud native versions, which are nowhere near this robust. So there's that. So let's get back into the content. I hope, what do you call it? Yeah, so if you're going to deal with enterprise architectures and multi-cloud, you need vendor interoperable services, not proprietary services. So it was like yesterday when we said, hey, multi-cloud, use MongoDB over DynamoDB. Don't use Amazon Aurora. Use MySQL, Postgres, MariaDB, etc., Oracle or Microsoft. And really, it's not because any of these services are not good. But in multi-cloud, we need interoperability. And if I speak Greek and Abigail speaks English, it's not going to be the best combination. Now, if Abigail speaks Greek and I speak Greek, we're speaking the same language. It's beautiful. If Abigail speaks English and I speak Greek and I got to translate my English to Greek, not everything translates exactly perfectly. So that's the problem. We want everything perfectly translated. So I hope you understand why we're doing what we are doing. So now we're going to get into the AWS proprietary applications and services. So we're going to go talk about them now. Now, again, multi-cloud, a lot of these services become unusable, but they're good services. There's nothing wrong with the services. They're excellent services. So I just want you to know what they are. They'll be on your exam. And then you have to learn the difference between certification training versus career training, which is why we have our career development program for the architects, the cloud architects, and our cloud engineering program. Because certification and the job are about 90% different, both of these careers. So in this section, we're going to talk a lot about things. We're going to talk about a simple queuing service, a simple notification service, a workflow service, mapping and reduction, streaming data with Kinesis. We're going to talk about container management and many, many, many more things. So we're going to begin with an exceptionally good service called Amazon Simple Queue Service. Now, unfortunately, I can't use this in any of my industries because it's AWS proprietary and I use Apache Kafka. But the Amazon Simple Queuing Service is an excellent queuing service and enables you to decouple your architecture. So if you see a test question, why are we using Amazon Simple Queuing Service? It is to decouple our application architectures, and it is an exceptionally good service if you're only on AWS. But if you're going to be on AWS, Google, and Azure, use Apache Kafka because it's vendor neutral, interoperable, and it works everywhere. But we're talking about the AWS proprietary queue service, which is a great queuing service. It's just proprietary. So what is SQS? It is a message queuing service that provides temporary storage of messages. What it does is it gives you a place to take messages before they're lost. So think about it. You got messages coming in really fast from your web server. They're hitting your application server. And now you got to send messages to the database. So if the database is busy and it's busy, the messages drop. What if you can put the messages in a swimming pool? Put the message in the swimming pool and then take each message out of the swimming pool as necessary. That's your queuing system, whether it's Apache Kafka or AWS simple queuing system. That's why we're using this. So queuing enhances application availability by providing a means to keep the messages from being lost. We can keep messages in there for 14 days, so we're not going to lose them. The queuing system is amazing because we can look at the depth of the message in the queue and say, add compute capacity, scale out, auto scale. Now, normally we auto scale based upon CPU usage, but if we can actually auto scale based upon messages, we are perfectly in tune. So I love the AWS SQS service. And don't get me wrong, if I'm on an AWS environment, I'm going to use this because it's really great. It's just that I don't have any customers that want to do single cloud. Everybody wants to do multi-cloud. And for those reasons, I can't use the proprietary things. But it's awesome. It really is. So here, this way this works. We got an order. Let's say the order comes in through the web server, hits the app server, and it has to hit the database, which in this case is reflected by Amazon DynamoDB. Again, another database, very proprietary, but beautiful database. So the messages come in from the web server, the app server, and they get stuck in SQS, and they sit in SQS until DynamoDB is ready for them. So big improvement in scalability and performance. Let's talk about the standard queues. So AWS, as normally speaking, it's really fast. Here's how the queue works. Message comes in, comes out as fast as possible. So that means when they come in and come out, they can. Now, there are times that you need messages to be delivered in order. And you can actually do that as well. And you can set this to what's called the FIFO queue, first in, first out queue, but you don't necessarily have to. So keep that in the back of your mind. So when you set a first in, first out queue, meaning message 1 comes before message 2, before message 3, realize it will lower the performance of the queuing system because sometimes small packets come through faster than big packets, but whatever the case may be. But if you need messages to be delivered in order, you can enable a FIFO or first in or first out queue. Now we can also create a dead letter queue, which is one of my favorite things. Here's what the dead letter queue is. If a message doesn't get delivered, we can keep it in there. So how's SQS work? Very simply. The message is sent from the computing platform to the queue. The message is in the queue, and it waits to get scheduled for delivery. If the destination is busy, it hangs out in the queue for a week or two, or as long as it can be. When the server is ready, it pulls the message from the queue to be processed. So it's going to look like this. Got our sender. We're sending our messages into the queue. Cool, right? The messages leave the queue and get sent to the receiver, and then they are drained from the queue, so they're not there anymore in the future. Simple, and elegant. So when do you use this simple queuing system? Well, you're going to use a queue anytime you want to increase capacity and promote application scalability through decoupling. If you want to make sure you don't lose orders or messages, which I strongly recommend, use a queue. Great for cost optimization, truthfully, because it enables you to right-size your applications, not oversize them for peaks. Helps smooth out your system, but also SQS, and we do love this. If you can look at the message queue depth and trigger auto scaling, then you are in a position to add capacity as you need it perfectly. So now let's talk about my new favorite thing called Amazon SNS, Simple Notification Service. So not my new favorite thing, it's just one of those things that I actually do like. Lots of times we need to be notified of what's going on in our system, and Amazon provides us a very simple, elegant solution called Simple Notification Service. And this is a great way to decouple messages. We can use it for fan out, so we can have a message that goes in to the Simple Notification Service. It can take the message and send it to a queue and send in a systems administrator an email. So this is great. So how does the Simple Notification Service work? Like an email list. It's called the publisher subscriber. So here's what happens. You subscribe to a topic, and the publisher presents to it. So you subscribe to an email list, and you get access to it. Same thing, simple notification service. So simple. We can use it to send an SMS message, an email, a push message to multiple devices. So, we're dealing with really great. Publishers who publishes, subscribers who subscribes. Think of a mailing list. So here's what we're talking about with regards to the concept. We can have a publisher send a message. The message can go to a queue and a Lambda function and be sent as an email or any kind of notification we want, all at the same time. So take a message, it's a message system. Beautiful. So let's talk a little bit more Amazon SNS. Let's talk about the platform functionality. It is a high availability platform that runs across multiple availability zones. Yes, we can use SNS to trigger a Lambda function if we decide to, etc. So it can use to be fanned out messages. It allows the creation of filter policies, so you only receive the notifications that you're interested in. And SNS will encrypt your messages immediately to prevent unauthorized access. Let's talk about some common SNS use cases. Application and systems alert. Hey, every time the CPU of a system is over 80%, notify all the systems modifiers. Or take a message, send it to SQS and a Lambda function at the same time. Or push a message to someone. Maybe a realtor showing some houses, puts a message that a new house went on sale. These are what we're dealing with simple notification service. The next service is called Amazon Simple Workflow Solution. So this is a workflow management solution. So look at it this way. Let's say you've got multiple tasks. Task 1, task 2, task 3, task 4, task 5. It would be really good if we can automate the moving from task to task and take people out of it. And that's what Amazon Simple Workflow Solution does. We love it. It's really cool. So SWF is a workflow management solution. It enables the coordination of different tasks across distributed application. It enables you to create a workflow of step-by-step tasks. And guess what? You don't need to code it because it's already pre-made. So I'll give you an example. Let's say, for example, I had a video processing thing where the steps are, I upload a video, and then it needs to be web optimized. So maybe you can take it from uncompressed video to render it out in H.265. And then maybe I want to get it sent to a transcription to add some captions. And then I want it to be put in an S3 bucket, and I want an email that says, Mike, it's ready for download, your new video of your cat. So I could create a workflow that once I upload it, it kicks off a Lambda function that sends it to the optimization thing. And once that's done, it sends it to the Amazon recognition for transcription or Amazon transcribe. And once that's done, kick off a Lambda function to send it to someplace else. That's what we're talking about, and we love that. So simple workflow solution is great. Now, the next thing we're going to talk about is mapping and reduction. So when we're dealing with data lakes and big data environments, here's what we're really talking about as a rule. We're talking about taking the data out of a relational database, taking the data out of a data warehouse, taking the data out of a NoSQL database, connecting it to object storage, harmonizing it normally. And normally, what people do is they use Apache Spark to do this. And most of the big data people that I'll tell you will write a custom Apache Spark script to do this, like a Python Spark script. Now, AWS Elastic MapReduce is a pre-made script that, for the most part, makes it that you don't have to create your own Apache Spark or Python Spark script. But, there's still going to take some tuning. So your big data people will choose to either write their own thing or use this AWS service to map it and reduce it. Really what it's about is architecturally it looks like this. You take your information from one thing, you map it, and you reduce it so it can go somewhere else. It's all about harmonizing, converting Greek to Greek, so to speak. Let's discuss Amazon Kinesis. Now, this is generally more of a certified solution architect professional thing, but guess what? I want you getting cloud hard. I want you to have the skills to be employable. So that's what we're talking about these things. So we're going to talk about Amazon Kinesis. Now, as a rule, I don't have any use for Kinesis, even though it is one of the greatest services in the world because it's AWS proprietary and my customers demand Apache Kafka. But in your certification exam, you will need to know about Amazon Kinesis. And Amazon Kinesis is an excellent service for streaming data. It's just AWS proprietary. So if you're going to use multiple clouds, this is one of those services that's not so great. If you're going to use a single cloud, this is a beautiful service. So Kinesis is a service for collecting, processing, and analyzing streaming data, just like Kafka. So Kinesis can collect and analyze your streaming data in real time, just like Apache Kafka. Kinesis can collect your data from your video, your audio, your application logs, your clickstreams, your IoT devices, just like Apache Kafka. And unlike a traditional environment where you're going to connect and store and analyze the function, here with Kinesis or Kafka, we can do it in real time. So we love it. That's the difference. Traditionally, you store your information in a data warehouse and you take historical information for a long period of time, analyze it to make your business decisions. Not here. In this particular environment, we've got something very special. In this particular environment, we are so good to go that we can use Kinesis to do this. Now, when we use Kinesis, there's 4 kinds of Kinesis. Kinesis video streams, Kinesis data streams, Kinesis Firehose, and Kinesis data analytics. And they all have different use cases. Let's talk about Kinesis data streams. It's really for video. It enables Kinesis to collect video from multiple sources. It enables the ingestion, the storing, and the indexing of multiple streams. And it enables videos obtained by Kinesis to be sent for media processing, machine learning. We love it. So here's what it's going to look like. Video coming in. It's going to be streamed over for video media processing. Let's talk about the data streams. Kinesis Data Streams is a highly scalable platform for real-time data. It can capture real-time data and send to a data analytics application within 70 milliseconds. It can capture gigabytes of data, gigabytes per second from hundreds of thousands of sources. So why are we doing this Kinesis data streams? I'm going to show you right now. We're taking these data stream into Kinesis so we can analyze it with a business intelligence tool like Power BI or Tableau or something like that, and actually see what's going on in real time. So, wow, my sales are doing this. Let me affect pricing this way or this way. So that's why we do these things. Let's talk about some key concepts with Kinesis. We've got a data producer and a data consumer. The data producer is an application that emits data records as they are generated on the Kinesis data stream. Data producers assign partition keys. A data consumer is basically someone who uses it. The distributed Kinesis application or AWS service retrieving the data from all shards in the stream. Now, what is a data stream? A data stream is a logical grouping of shards. Shards are a measure of throughput. So what's Kinesis data streams used for? Well, large event data collection, real-time analytics, gaming data, mobile data, etc. Great stuff. Now, the question that we want to really talk about under here is Kinesis Data Firehose is a managed service to load streaming data into something like S3 or Redshift. So that's the last way we can do it. We can take our data through Kinesis Firehose and store it somewhere. So let's go through these. Kinesis video streams for video. Kinesis data streams to analyze real-time data. Kinesis data Firehose, store it somewhere. And now let's talk about Kinesis data analytics. Kinesis data analytics is a managed service to transform analyzing streaming data in real time. And it's basically based on Apache Flink to process data. Kinesis streams is auto-scaling and it'll meet your needs. But here's the key. The data on Kinesis streams that's being aggregated and collected can be done with with standard SQL queries. Bear with me for 1 second. I have an idea. I don't know if my team can do it, so bear with me. So let's talk though about the last thing, Kinesis data analytics. Basically what's going to happen, it's going to look like something in this particular situation where we're going to be taking our data in real time, running it through Kinesis analytics and looking at it a tool like Power BI in order to make this a really, really great end-to-end solution. So that's what we're doing. Kinesis is all about getting information. So now let's talk about something. Now we're going to talk about two things. We're going to talk about something extremely proprietary, which I'm going to recommend you don't use. And then we're going to talk about something more interoperable, which you could use. And then I'm going to give you another way where you can do it, where you don't have any of these things to worry about. So in the cloud, we're going to be dealing with containers and virtual machines. That's all of our compute for the most part. So virtual machines, we know how that works. Now containers, there's three ways we can do it. There's an Amazon Elastic Container Service, which is a proprietary container management platform. There is the AWS Elastic Kubernetes Service, which we'll talk about, which is an AWS managed kind of program. And then let's talk about the third thing that we're actually talking about, which is you build your own and manage your own Kubernetes cluster in every way you want, and it becomes a really great environment. So kind of keep that in the back of your mind. So we'll start with the Amazon Proprietary Management Platform. The proprietary management platform is as follows. We can use the Amazon Elastic Container Service, which is basically a service that manages your containers. And realistically speaking, so the container management system manages your containers, and therefore you don't have to create a container orchestration thing. So the Elastic Container Service is going to look like this. It's going to, you'll see your server, you'll have your operating system and your container. So basically you'll create a virtual machine, and on the virtual machine, you'll put all your containers, and it'll be managed by the Elastic Container Service. Or there's a serverless environment we can put our containers called Fargate, which we'll get to less. But the Elastic Container Service is an Amazon proprietary container management service. So guess what? I don't recommend you use this. It's proprietary in every way. So we'll talk about something that's going to work much better in a minute, but I wanted you to understand what this was. The Elastic Container Service is a fully managed container management service. 4 nines availability, so relatively decent availability. And it's going to be deployed in your VPC, which means you can use network ACL security groups to lock your system down. And you can put your containers in a virtual machine, like an EC2 instance or Fargate. So what's that going to look like? It's going to look like this. Without Fargate, you're going to see this. You're going to have your container management service, and this will be used to orchestrate the container. So it's kind of like the conductor of the situation. So you'll then build your containers, put your containers in a virtual machine, isolate the applications in special containers, manage them, and you'll be doing that. So that is the standard way to do it. Basically speaking, you put it on a virtual machine. This is what we do in our data center. So in our data center, we have a container management cluster. It's usually OpenStack or Kubernetes, industry standard, but whatever. Let's say the AWS proprietary Elastic Container Service does this. And it does it in a serverless manner, so there's nothing for you to patch. Now, you've got a choice. You put those virtual machines on a virtual machine, or you stick them in this serverless environment like we show you. Use the Elastic Container Service that manages the cluster. You stick your stuff on Fargate, which is a place to host your containers, and you are done. And life is so easy. So now you know about the Elastic Container Service. We're going to go into the more vendor-neutral, interoperable services, but let me see if I can stop for 10 minutes. Also, here's what I want to do, and if you guys are with me. I'm thinking that it's Easter weekend and nobody's really going to want to come in on a Saturday to do this. I know that we can finish up today by about 4 to 4:30 if we keep going. So we're going to run until 4 p.m. so you guys can get all your great cloud training, and not only get your cloud training so you can get cloud hired, but you'll have the whole weekend off and you can go through the course a second time if you want to learn some stuff. So bear with me. Stay a little late. We'll make it a great thing. We'll get out of here before the end of the day and you have your weekend free. So If you've got some questions, let's answer them, and then we'll get back to the content. We've been making lots of great strides today. Can S2S trigger a Lambda function? Absolutely. You're thinking like a cloud, like the cloud people. I'm loving that. Good job, Sujith. If you've got some questions, please feel free to ask them. The only question that I saw that recently came up that wasn't related to tech is how much different is our cloud architect and cloud engineering program? Completely, because the cloud architect job and the cloud engineering job couldn't be further separate apart. So we train for the job we want. And we'll be able to do that on Monday afternoon for much, much, much more details. But let me tell you, when we train somebody for a job, we train them for that job. And here's the reason why. Pilots don't become pilots by learning to be flight attendants. Doctors don't become nurses. Doctors don't go to nursing school to learn medicine because it's a different job. So when our programs are different, they are based on getting you hired, paid the most, and promoted, and having the best, fastest career progression. So keep that in the back of your mind. So vote on the next boot camp. Do you want Azure or do you want Google? All I care is we give you what you need so you get cloud hired. So tell us what you want. We aim to please. So if there are no more questions, I'm going to get back to the content. Oh, one more thing. I forgot to tell you, my team decided to take the sale while I asked them and extend it all weekend. So if you want to become a cloud engineer, now's your time. Want to become a cloud architect? Now's your time. If you've been training for a year and you need help with the interviews, now's your time for the Tech Interview Mastery Program. And if you've been working in tech and you want to move up into management, you want a leadership position or something like that, we've got our Tech Career Accelerator Program. And guess what? They're all 30% off except for the military course, which right now is 50% off. This is brand new. If there's no more questions, we're going to get back to them. But if you give me a hashtag cloud hired and a hashtag cloud engineer or a cloud architect based upon your desired career, they'll be there. There is one question between a Lambda function. So a Lambda function is just the ability to do something very basic. Send an email, notify you that a bucket's there. So Lambda function is trivial. Microservices is basically Kubernetes, where instead of having a big monolithic application, we chop the application into many, many services inside of containers that are self-healing. So that's more of what we're talking about. Lambda, simple functions, little mini things, versus microservices are a whole way to design an application. But good question. So, getting back to the content here. Now let's talk about another container management platform, a good one, the Amazon Elastic Kubernetes service. Now we're getting some really, really great stuff. And now we've got Amazon that's got a normal de facto standard managed Kubernetes service, and everybody uses Kubernetes. Kubernetes is OpenStack. Kubernetes is the de facto standard for container management. And here we've got the AWS Kubernetes management service, which is a full management service. So now what we're doing is as following. Here we've got a professional vendor interoperability orchestration system. So if we've got a Kubernetes container in our data center, we can just move that Kubernetes container in here. If we're dealing with multiple clouds and Amazon has their Kubernetes and AWS has their, and Azure has their Kubernetes, it's still Kubernetes. So realistically speaking, I'm going to tell you how I would do it, and it would still not be this either. But guess what? This Amazon Elastic Kubernetes fully managed service is excellent. It's vendor interoperable. It's industry standard. And here's the two ways you can use it. You can do it as following. We can set it up in either containers or serverless. So let's imagine we use the Amazon ECS. We set up a virtual machine like we have on the right side of this screen. We can put all our containers in the virtual machine. This is identical, effectively speaking, to what we'd have in the data center. Or we can host them in the service environment called Fargate. I host my stuff on virtual machines, and here's the reason why. Doesn't work well with AWS. I take my virtual machine, I move it to Azure, Google. 5 minutes later, everything's up and running. So that's the way I do it. But I like to give my customers the most options to be able there. So I'm not going to be using Fargate. I'm going to be using virtual machines. But there's a time and a place to go serverless. But understand this. When you are serverless and you bring customers to serverless, it is very hard for them to leave. So the cloud providers are kind of like the cable company. You join them, they give you 30, 40% off in your first year, like a drug dealer would do. And then after a year, they raise your rate when you're stuck on them. And if you're using serverless, you can't leave without spending lots of money. So you put your stuff on Fargate, it's fully managed, it's in a container. You have less ability to get in and get off as easily as you could if you put your systems on a virtual machine. So when should you use this? If you want a fully managed Kubernetes service, this is brilliant. It is industry standard, it is interoperable, and it's great. Want to know another way to do this? Take a virtual machine, install the Kubernetes service, have that running in your data center and take clouds and have them all orchestrate together. Guess what? Perfectly interoperable too. So make your own Kubernetes service. Use the Amazon Elastic Kubernetes service. Both of these are great. Both of these are interoperable. They work. They're enterprise friendly. What's not? Elastic Container Service. You know why? It's not interoperable. So your Kubernetes containers aren't going to work there. So kind of keep that in the back of your mind. If you're going to design things and you want interoperability, use industry standards, and the Elastic Kubernetes Service is awesome. The next service we're going to talk about is the Amazon Elastic Beanstalk. I'm going to give you a secret. Whenever you do anything that's automatic, it's never good. So design your systems yourself. But if you're not skilled and you don't know and you're brand new to cloud, well, the reality is you shouldn't be touching the cloud. But if you were going to, Amazon has something called Elastic Beanstalk. And for the most part, this is a service for provisioning, deploying, and scaling your applications. Basically, you upload your code and automatically AWS designs your architecture, load balances, and puts it together for you from your code. So kind of keep that, just know what it is. But, if you want somebody to build your car based on average, there's that. So Elastic Beanstalk is a technically driven, semi-automated to do it. You upload your code in Go, Java, .NET, Node.js, PHP, Python, or Ruby, and it does its thing in the back end. It'll be using CloudWatch to monitor your logs. So, it's simple and elegant. It really is. But after being an engineer and an architect for 25 years, I'm going to tell you, Automagic is not something you want. And they used to call it Automagic because it was like automatically it does it. Only problem, it doesn't. And when it does automatically, isn't ever what you want it to be. So user uploads their code, it auto deploys their stuff, and theoretically it's all going to work and auto scale and auto everything. But I don't do auto anything. I'm an architect. I design systems. My systems are based upon what makes the customer's business better, not some arbitrary tech. So there's no point in an architect's life for using like this, because what are we doing? We're designing technology to solve customer problems. And if you're a cloud engineer, you should know so much about that technology, you'd still want to use this because you're going to do it the way you want to deploy what you want, how you want it. You want it deployed with perfection. So take the time, the care to do some manual intervention. Now let's talk about CloudWatch. I love CloudWatch. CloudWatch is logging or monitoring. So CloudWatch provides lots of metrics for you to monitor your stuff. Everything we deal with has logs. CloudWatch can work with some built-in metrics or custom metrics. Here's the thing with CloudWatch. It's giving you logs. It's giving you information, so it enables you to collect, monitor, act, and analyze your information. CloudWatch is great. Now, when it comes to CloudWatch, we have built-in metrics and custom metrics. Now, the built-in CloudWatch metrics are pretty terrible. Their CPU utilization, their disk read write in terms of IOPS, and network utilization, and that is it. So if we want real information, memory performance, API performance, or anything else, then we're going to have to get CloudWatch custom metrics we're going to have to set up. And what is CloudWatch? It's really a notification system that lets customers know when they see things. That's more your CloudWatch events, which is also often called Event Bridge. And CloudWatch events are awesome. CloudWatch events enable you to do the following. Look at something that happens in auto scale, kick off a Lambda function, an SNS notification, or guess what? Even fix something. You could have a CloudWatch event that something happened in S3. You can kick off a Lambda function to remediate it. So this is really, 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 really be awesome. So when you set up CloudWatch, there's two versions. There's basic monitoring and there's detailed monitoring. With basic monitoring, data is available every 5 minutes at no charge. Now, here's the thing. If any of you have done monitoring and you look at your data every 5 minutes, you can have a peak of 100% and a low at a 0% that averages at 50%, and you'll miss things because it's too infrequent. Detailed monitoring you can do, which gives you data every minute, but you got to pay extra for it. So it's like anything else in the cloud. Do you want the good stuff, the real stuff that you would use in the data center, then you're going to pay for it. And if you want the amateur stuff, then you pay less for it, or it's free. So when we're dealing with CloudWatch events, and what we're really talking to is as follows. CloudWatch events deliver near real-time streams of events. So basically, as soon as something happens, you can get told about it. So I kind of like this. Something happens, So what is CloudWatch? CloudWatch is giving you notifications, etc., etc., etc. I'm going to get to CloudTrail, but I'm going to just quick as Kelp Sunny's thing. Using Elastic Beanstalk to automatically create and design things for you is going to create and design things that don't work. Now, that's very different, Kelp Sunny, than, for example, if we take our environment and we deal with the DevOps team and they create an infrastructure as code for exactly what we have replicated. And then we could use that infrastructure as code to redeploy it in another cloud. But we're going to be using Terraform for that and not something like an Elastic Beanstalk to design its own and hope it works. We're not going to hope it works. We're going to create a real architecture that's going to match our architecture that we designed, and our DevOps engineers will do it with Terraform across all clouds because the same code will work. But it was a great question, Kelp Sunny, and that's why I brought it there. Now, if CloudWatch is logging, remember this, it's a test question. CloudWatch monitoring, CloudWatch logging, CloudWatch logging, CloudWatch logging, CloudWatch logging. Gotcha. Now, let's think. Let's go from CloudWatch logging to auditing. So on your test, you will be heard of CloudWatch, which is logging, and CloudTrail, which is auditing. So CloudTrail is auditing, CloudTrail is auditing. Why? I don't want you getting those two questions wrong, or three or more. So now you know that CloudWatch is for logging and CloudTrail is for auditing. So now we're going to talk about CloudTrail. CloudTrail is an AWS service that helps with auditing. It provides an audit log that assists with risk management compliance, really useful in regulated industries, for example, like medical or financial. CloudTrail is awesome. It's going to track what changes was made to an AWS account by user, role, or service. CloudTrail is enabled as soon as you enable your account. But in order to use it, you have to start to create a trail, which you do in the CloudLaunch console, the CLI, or the API. And CloudTrail will record events. And these events are visible in the CloudTrail console under event history. CloudTrail is something you're going to use a lot of. So great service, great service, great service. The event history will let you view events that have occurred in the last 90 days. Additionally, CloudTrail can be configured to store logs in S3 for long-term storage. Guess what else it'll do? We can create a CloudTrail that applies to one region, which is just in a single region, which is going to store your information and your logs in a single bucket. That's your default. Or you want comprehensive auditing? We can create a trail that applies to all regions. And this is going to provide the most comprehensive logging and auditing. It's going to provide a record of all events that have occurred in the organization structure. And know what's cool about this? When you see a problem, you'll be able to see what's going on here, 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 and here. And that's how you're going to get to the solution. So visually, what's it going to look like? I'll show you right now. CloudTrail. You get logs from all this stuff. Who did what, when, how, where, and why. And you're storing it in your object storage. So you can go back there for future use. So pretty cool stuff. We love CloudTrail. We love CloudWatch. You've got to do monitoring. Now we're going to talk about AWS Config, another AWS service. Guess what this one's for? So this is a service that enables the assessment, auditing, and evaluation of configuration. It provides an opportunity to see what changes were made by whom in your environment. So config tracks changes. I love this. Changes made. AWS Config can send a simple notification alert. So you can get an email, a text message, a push message when somebody does something. Now, why is this important? Okay, Joey comes in. Joey makes a change. The change Joey makes our systems hack because his change opened this, and this. As soon as Joey makes those changes, because we're using SNS, we systems admins get a notification that says, Joey, the change. And we, oh, look at Joey's change, and we go, oh no! And we get in there, we call Joey, and we say, Joey, do me a favor, stop touching the tech. And we go in and we fix Joey's mistakes instantly, and then we don't get hacked. So AWS Config is amazing. It provides a means to help with change management, identify things that somebody did. So, it's not that different than CloudTrail, which gives you audit logs, but this is more real time. You get to see it when it's occurring and how it's occurring, as opposed to finding out in CloudTrail a month later that something happened. So how does it work? Like this. Somebody makes a configure change. AWS Config notes the change and records it in a format. And then Config will have to check the change. Does it meet the organization's policies? If so, great. If not, ding, 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 emergency, bad problem, sound off the fire alarm. Notify the systems admins that changes have occurred and they're not good changes. So that's what we're really talking about with Config. And it's a great service. I mean, it is a really, really great service. So configuration change, Config tells everybody, and life is good. As they say in some parts of the world, Bob's your uncle. Okay, now we're going to get into the AWS Content Delivery Network CloudFront. And guess what? CloudFront is awesome, and it's going to be fun talking about it. But it covered some logging services, some monitoring service, some etc. So if there's about 3 to 5 minutes of question we can answer them, and then we'll go back to the training. Chris, did I miss any questions in those last 5 minutes when we went through those services?
I don't think so. Oh, one just. I think you got this one. Did you get this one?
Yes, I covered the difference. So
right.
CloudTrail basically covers long-term logs. Config basically gives you closer to real-time configurations. AWS Config can be used security monitoring along with 40 or 50 other tools for a comprehensive program. Absolutely. In SQS, if you have no data clue, does the failed message become like a zombie? Yes. But if you've got a dead letter queue, which what he's asking for is when you're using a queuing system, if the queuing system has a 2-week delivery and it doesn't get drained out of the queue, the message is going to be lost. And what we can do is set up a dead letter queue. And a dead letter queue comes from the post office days. And here's what a dead letter queue is. The postman or postwoman goes to deliver them messages and they can't. They pop it in this box and then they try and figure out how to deliver them as a secondary case. That's what a dead letter queue is. And yes, making a dead letter queue when you're dealing with queuing systems is a very smart thing to do, so you don't lose messages. Absolutely. Great question.
And that was it so far.
Okay, then content delivery networks it is. Woohoo, because this is really important stuff now. And content delivery networks, let me tell you, are one of the most important things. And I will tell you that they are almost exclusively described incorrectly. In fact, even if you read the AWS documentation, they don't tell you about the content delivery network at all. They only tell you about their caching servers, which is only half of the content delivery network. So we're going to explain it all. So you're a real architect, real engineer, and you know how to do it in real life, not just what you've heard in the certification. So we're going to talk about AWS CloudFront, which is the Amazon branded content delivery network. And what is a content delivery network? You'll hear people say it's a geographically distributed set of servers to provide fast content delivery. And yes, it's that, but what's that missing? The network. So really, the content delivery networks are about optimization and networking and performance. So content delivery networks will reduce your bandwidth costs, they'll reduce your server loads, and they will improve your speed and performance. Content delivery networks do a world of good for your internet security, and here's why. The request comes to the content delivery network. It's a bad request. The content delivery network says, go away. You're not real. So totally protecting the web server. So content delivery networks, website scalability, network scalability, performance improvements, decreased interregional charges, and higher availability. So it's great in every way. So imagine this. You've got a web server. It's down for 30 seconds, but the information is cached on the content delivery network. Some users are still getting service. So content delivery networks are awesome. And we're talking about AWS, we're talking about CloudFront, because that's their branded content delivery network. So CloudFront can really help boost your website for hosting performance. And it's got a network and a set of caching servers, but the network is really the critical thing. And we're going to show you how this works. So how does it work? So right now, here I am in my house. I'm home, it's a Friday, and I go to a website that says www.gocloudcareers.com. And I go to this website. Now, the first time I go to this website, guess what? I go to my regional location. It's not there. So the CloudFront Content Delivery Network says, okay, Mike, and it sends it up the private network to the source. And the web server answers. So the web server from www.gocloudcareers.com sends the information to the regional cache across the content delivery network, then sends it to the Miami CloudFront location, then gives it to me. Now, 10 minutes later, my cat Cindy decides she's going to the internet. My cat Cindy's a genius. She's an expert troubleshooting coach by unplugging servers and chewing through Ethernet cables and powering off switches with her paws. And she decides to go to www.gocloudcareers.com because my cat wants to become a cloud architect. So she goes to www.gocloudcareers.com. My cat goes there. Now, because I went there before Cindy the cat went to my website, she got it immediately. Now, my wife decides she's going to give up practicing cardiology and she's going to be a cloud engineer. So she goes to the www.gocloudcareers.com webpage, who I went to, who Cindy went to. And as soon as she gets there, it's here on the cache. So the only time the web server answered was for me. When Cindy went there, when my wife Lisa went there, it didn't go back again. So kind of keep it that. So the way these content delivery networks work as follows. Let's say we've got a statically hosted Go Cloud Careers page. My first request, guess what? It hits the content delivery network and it's not there. So it goes through the content delivery network to the source, which is my VPC or whatever, or the S3 bucket. The S3 bucket then provides the information to the CloudFront content delivery network and sends it to me. So the next user that wants to request something goes to the CloudFront and CloudFront says, I already have it, here you go. So this back end was only seen one time for everybody in that region until the cache dies out. So, this is really cool. So when we talk about CloudFront or content delivery networks, we're talking about caching to make the website more scalable. We're talking about caching, which offloads the servers by taking frequent requests to the cache. So the servers are less busy. So for frequently accessed content, it helps. If the content is not as dynamic and it changes, the queue doesn't help, because if I go to requesting different information than Cindy versus Lisa, guess what? None of us have the information stored in the cache. So keep that in the back of your mind. And when we're dealing with AWS, CloudFront integrates pretty much everything. Why? Because it's a great content delivery network and we do so much web applications on the web. So whether we're dealing with S3, EC2, load balancers, or Route 53, we can stick CloudFront there. CloudFront is often used to front-end a static website stored in object storage like S3, but it can also be a front-end to a virtual machine-based website, assuming a load balancer is used as part of the architecture. So let me show you what it looks like. Realistically speaking, we've got the user. They access CloudFront. They can either pull static content from an S3 bucket, or they can get dynamic content from a load balancer that's front-ending excuse me, some virtual machines. That's pretty much it. So let's talk about some key CloudFront concepts. We're dealing with concepts. There's three things we need to talk about: distributions, origins, and cache control. So when you set up CloudFront, you're setting up a distribution. And a distribution is going to be identified by a DNS name. And remember, when we looked at Amazon, it was an ugly name, like abcdefg1234.cloudfront.net. And that's not a pretty name. So what you can do is you can leave that as the URL for your website, and I wouldn't. Or you can create a CNAME record. Cindy the Cat maps to abcdefghijk1234.cloudfront.net. And now you go Cindy the Cat versus that ridiculous thing, and you find the website. So now you know, and I showed you that yesterday when we were looking at the, what's the word I'm looking for? I showed you that yesterday. So let's talk about the CloudFront origin. Yesterday we did that when I did an NS lookup of Amazon.com. So let's talk about the Amazon CloudFront origin. When you set up a CloudFront, you set up an origin. So what's the origin? It's the location of where your content's coming from: an S3 bucket, an EC2 instance or virtual machine, your load balancer, etc. And the origin is going to point to the DNS name of the location. So let's talk about CloudFront cache control. So CloudFront's about caching, right? So let's think about this. If I cache my website, www.gocloudcareers.com, and it's cached out there, and the cache is for a month. Every single time somebody hits the cache, the information will be there for 30 days after it's first populated. Now, if it's there for 30 days and I change my website, guess what? For up to 30 days, people are going to get access to the old information. So with a cache, we've got two options. How long do we keep information in the cache, which is called time to live? So let's think about the time to live alternatives for a minute. If we've got an incredibly long time to live, like a month, the data can be stale that's being served on the content delivery network for up to 30 days. If the cache changes every 5 minutes, then it's going to get new content every 5 minutes. But 5 minutes later, after I request information, it won't be on the cache, so my web servers are going to work. So what we need to do as architects is find the intersection of the most scalability that we need by the length of how long it can be, combined with how frequently we change the content so we don't have scaled content. So you, as an architect or an engineer, will need to know the needs of the business to say whether the content should be there for a month, for example, or a minute. And realistically speaking, I'm exaggerating the concept, but you really need to know exactly how long your content should be there. So when you do this, you have to let it know what you need. So when you set up CloudFront, you're basically setting up your web servers and you're putting your content on. Then you're creating your CloudFront distribution. And AWS will assign a name for the distribution. And then either you accept the ugly thing or you go back to the CNAME record. So let's look at it in real time. Let's put all the things together. So we've got the user. The user wants to go to www.gocloudcareers.com, and we're using the AWS Content Delivery Network. So we got the user in the top right corner here. The user goes to www.gocloudcareers.com. So the user goes to the edge location. It's not there. So the edge location goes to the regional cache. Guess what? It's not there. So the edge location sends it to the source. Now, the source, the EC2 instance in the S3 bucket, they then send all the information back to the regional cache, back to the edge location, and back to me. And I'm all happy because I got to find Go Cloud Careers. Now, Jonathan comes, and he's also in Florida, and he goes to that same edge location. He requests that Go Cloud Careers website, and he sent it instantly. Now Ray is interested. He goes to the Go Cloud Careers website, hits that same edge location, and he gets it. And all's good. Now we've got Chris, who doesn't live near Miami. He lives near Tampa. It's his major city near him. So Chris goes to the Tampa edge location. And guess what? There's nobody there. So he requests her from the edge location. It goes to the regional cache. It goes to the source, back to the regional cache, back to the edge location, and back to Chris. Now, Chris is doing great. Now, somebody else is in the Tampa area. They go to the same website. They get sent here. Now, we set the cache for 3 hours. It's been 6 hours since any of us requested this. The next user on the top wants to have it. The cache is timed out. He or she goes to www.gocollectcareers. It hits the edge location. It's not there. It hits the regional cache, goes to the servers, back to the regional cache, back to the edge location, back to the users, and poof, everybody is working. So that's the interplay. Now, here's the other secret that you need to know. The internet has no guarantees. The internet doesn't have to deliver your traffic. So while everybody talks about this concept, here's the thing. When the user in the upper left-hand corner goes to that edge location, if it's not in the edge location, it's going to ride a private AWS-owned network back to the source. So we're taking our traffic from the ugly, slow public internet into the AWS private network on the way to our servers. So we get acceleration in every case, acceleration of the private network, acceleration from caching. And that's why it's called the content delivery network and not a content delivery caching servers, because that network piece is the most critical piece of it. It's also the piece that AWS doesn't talk about on their website or in their certifications. It's the network that makes this so good. Getting off of the internet and onto a private network. So, if we're using CloudFront, what about private content? Well, we can deal with that too. How does this work? If you've got a private, you normally use CloudFront for a public website. But what if you have paid website subscribers, private applications, and you wanted to make it private? Well, you can do that too. There's 3 ways you can do this. You can set up an origin access identity, and you'll definitely see that on the Certified Solution Architect Professional, and most likely the Associate. And basically, you can restrict the area to a certain set of people. You can sign your URLs, etc., 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 where you can use a signed cookie. But these are the ways you can give private content. So going back to CloudFront, look, it's a content delivery network, so it can really boost your performance through content caching and through a private routing efficiency, a private network. CloudFront maintains connections to the source, persistent connections. So there's not going to be a need to start a new session with the server every time, further reducing the load. At the time of writing, there were 217 points of presence where CloudFront is used. So a lot of this. We'll talk a little bit more about CloudFront. You can put WAF or Web Application Firewall or DDoS protection as we described in Shield. Shield standard is included at no cost. Because CloudFront is a content delivery network and only forwards good legitimate requests to the servers, and it drops everything else, it's going to really help with DDoS protection. Because you can't launch an attack by sending bad messages through a content delivery network that just drops all the bad messages. And the good news is CloudWatch can also provide encryption in transit. By doing so, it takes the load off of the server. It can enforce an SSL or TLS protocol. And it supports server name identification and custom SSL TLS certificates. So that's CloudFront. Then we're getting it into a few more things before we're done for the day. But CloudFront's a pretty big topic, so I want to give it 5 minutes to see if anybody needs anything, and then we're going to go straight back to the content. If there's any questions for me from the CloudFront, let me know. Ruth, does CloudFront also use the edge location? Absolutely. That's where the user connects to the edge location. Great question, Ruth. Jonathan, does CloudFront only reflect content when the user requests it? Yes, when you request it. Although with some of these content delivery networks, you can pre-request it ahead of time, and that is possible. Is CloudFront proprietary? Yes, it's an AWS proprietary content delivery network. And the reality is all content delivery networks are owned by somebody and somewhat proprietary. So, you might have a AWS content delivery network and an Azure content delivery network at the same time. Yeah, you know, I got to tell you this. So when I teach live classes, it's easy because I can look at the expressions on my student faces. If I feel like they're overloaded, I can back off and we can talk about a catch for 5 minutes and answer some questions. And I do that, not being able to see anybody's faces, not know who's tired, not know who's fully overloaded, not knowing who needs a break. Yes, this makes it really challenging. So for all of those guys who are out there, that's why I keep that chat window. Please communicate with me. I want to give you the best experience. It's very easy for us. It's very easy for the student, but very challenging for the presenter. But we love doing this. I want everybody in the world getting hired, and I want to help you get there. So uncomfortable, comfortable, we're just thrilled to be with you. My gosh, all these days, such awesome and usable content. Thank you so much, Mike and Chris, and the Blue Crew for delivering such great presentations. Yes, the Blue Crew and Chris. Is there a way to clear the cache? There is absolutely a way to clear the cache. Just like anything else, there is a time and a place to kill the cache. And if you ever wanted to do it, what you do, there's a command. I'm going to put the command in the chat box. The last time I checked, it was create invalidation, and I just posted it there. A single command that clears out the cache. Will so too, good question. We covered it in the first day, so go back and look at that, but I'll also give you the answer right now. An edge location is where a user accesses a content delivering network. A local zone, by comparison, is where we do edge computing. So the reason we do edge computing is our data centers. Fast, and good performance. The cloud is far away, so it's slow in terms of latency. The point of an edge of a local zone is you can stick someplace in between you and the cloud provider that's far, so you can get closer to traditional data center like performance, closer, and still be using cloud computing. So that's what a local zone is. Get your computing closer to the user so it performs closer to the traditional network and data center environment and less like a cloud, because the cloud doesn't perform as well. It scales better, it's more agile, and it makes sense, but we can do greater things at higher performance in the data center than we could in the cloud, especially with regards to latency. What type of security do you use on CloudFront? Truthfully, on CloudFront, the only security I would be using is Shield. And then behind CloudFront, I would be using a next generation firewalls, IDS, IPS systems, access control lists, security groups, endpoint protection, anti-malware protection, host-based firewalls, host-based IDS, IPS systems, encrypted storage, get really good identity and access management profiles, and we're just beginning to touch security over there, Ruth. Good question, though. Now, Matt, here's the scariness. When you're dealing with an outsourced provider, they manage everything. They do, which doesn't necessarily mean it's going to be good or not, which means you may have to clear the cache. But it's a very solid question. Cloud providers, they generally manage most of their stuff. Can you tie Route 53 to CloudFront? I sure can. So whenever you create a CloudFront distribution, you will get a really ugly name. So, for example, let's see if I have the ability to do this. And I don't know if it's going to work. Share screen. Let me see if I have the ability to do this. Open preferences. Don't know if I can do this. If I can, what I'll actually do is as follows. I will, oh, nope, I can't do that. So I can't share that screen. Let me go find another slide where I'll show you what it actually looks like. I'm going to cancel my way out of this because that's not going to work out well. So let me go find a slide that I'll show you yesterday. And here's what's going to happen. And we're on slide 454, Chris. So you can remind me when we want to go back to it. Let me show you what it's going to look like. Bear with me a minute to go find it. I took a picture of an MS lookup from my computer. If I can find it, bear with me a minute. Okay, here we go. So what you're going to see is as follows. The second you create a content delivery network, what you're going to see is, this is going to be your CloudFront distribution. This Delta 3 Alpha Golf 4 Hotel Uniform Kilo Hotel 62 Yankee November.cloudfront.net. That is actually the name that you're going to get from your CloudFront distribution. It's going to be something ugly like that. So what you really need to do is as follows. You're going to take a CNAME MAC record, which Amazon did, that mapped Amazon.com to CloudFront.net. And we got to get to the thing that Up and Running put there, because that's not accurate at all. At all. And I want to make sure that we solve this issue. So the edge locations are not the backbone. The backbone of the network or routers switch inside of the organization. They're running an interior gateway protocol such as OSPF or intermediate systems. As a general rule, what they're going to be doing is they're also going to be running some RSVP signaling, and they're going to be running some tag switching or label switching. That's going to be the backbone, and it's going to have a bunch of explicit MPLS tunnels. Now, outside of the backbone, we have other entities, and that's what the edge locations are. It's not going to be part of that organization's major backbone. That's going to be specific systems in their network. They're going to be running multiple 100 gig links to each other. And that's where the routing and switching people like me are going to be designing their backbone. Their backbone is this. This is a content delivery network, which is separated from their backbone, that connects to their backbone, but not their backbone, to enable users on this. Their backbone is very isolated from this. And if it's not, every time they have an internet hiccup, they'll have an Amazon outage. So totally different. It's not where the backbone ends at all. It's part of another part of the network that gets attached back. So wanted to make sure we kept that kind of clear. Backbone is very specific. It is the heart of the network, the internal network, not the external network. So yeah, sure. If you have a website and you want to do web caching, you're going to use CloudFront. When are you going to use a NAT gateway? You use a NAT gateway anytime you want to translate a private address to a public address for egress-only internet access, meaning go out to the internet and bring your traffic back. API gateways are just ways to integrate into certain systems, and you can use that kind of the front end of microservice-based architecture, but most things aren't microservice-based architectures, so you're not going to be using as many. So keep that in the back of your mind. But good questions. Good questions. Were there any others I needed to get to?
That's it.
Okay, then we'll go back to slide 454. Bear with me while I find that slide, and we're going to get back to the content.
We did have a question come in, I think, from Up and Running.
So, and yes, the connection from the edge is going in, but that's still different than the backbone. The backbone is the core of a systems network. And typically what we have is we have a core, which is our internal major stuff. We have a distribution layer, which connects to the core and aggregates the access layer. And then we have the access layer of the system where it's fed into the network. And that's what we're talking about with CloudFront. It's an access layer, not a core. So that's why it's not part of the backbone. It's not even part of the distribution layer. It's part of the access layer. Access layer is a user access layer. And it's a very different thing. And there's extremely different routing on the service provider side. So that's what I was trying to say. They're not even there at all. They're totally separate networks. And they're probably running different routing. And they've got a lot of firewalling in between them. And they've got probably even a separate autonomous system. It's definitely not their backbone. But I know why you were thinking that. I just want, I have a lot of network engineers and network architects and people that really have a networking background. And because most of the cloud architects I deal with need a networking background, we got to be very precision on our networking. And that's why I was being extra careful here. I wasn't trying to be difficult. So now let's talk about Amazon Lambda. And we're talking about Lambda. We're talking about a serverless service for basic stuff. Basically, you upload mini code and it happens. And there's no operating systems to manage, etc. But this is for many stuff, many things. So it's a C#, Go, Java, Node.js, Python thing, but a very, very simple thing. Very basic stuff. And Lambda is stateless. And what I mean by stateless means it's not paying attention to anything at all. So once something happens, it's done, meaning it doesn't maintain it. So if you want to do a Lambda function, another Lambda function, another Lambda function, you need a workflow to synchronize them. So keep that in the back of your mind. Lambda itself is stateless. If an S3 bucket becomes public and you kick the Lambda function to seal it off, that's what we're dealing with. But once the function is performed, it's completed. Now, Lambda is really, really useful. So get a system event log, do something about it. Remediate a security thing, patching operating systems. So Lambda functions are brilliant. They're highly, highly useful in a variety of situations. And every cloud has it. Azure calls it a function. Basically, it's a little mini code in response to something. And that's one of the things that makes the cloud so transformational, is we can do these little mini things. So we can set Lambda to work off in response to some event in a VPC, like if somebody put a file in a new bucket. Think about this. Let's say I've got an application where I've got a user who uploads something into a bucket, which is something I do. A Lambda function can say, hey, send it to video processing. And another Lambda function can say, hey, send it to transcription. And another Lambda function could be, hey, send it to the end. So I hope that makes sense. So when we look at Lambda functions, and they are truthfully very cool, and they cover them in much more depth in the professional exam, what we're dealing with is here. In this particular example, let's say I had uploaded my video to S3. I could have a Lambda function that sends it and does so much work for me. So that's kind of all we're talking about is Lambda. Now, if Lambda is working inside of AWS, on the AWS network, inside of our VPC, what if we wanted to run little Lambda functions before they get to us, before they're even on our systems? Well, we could do that too, and that's called Lambda at Edge. And Lambda at Edge enables you to make Lambda functions, where do you think? Close to the user at the edge location. So that's all that is. Now, I previously told you that these little mini Lambda functions are cool. Awesome, right? But I said they weren't stateful and they couldn't remember. So going back to my video thing, I upload a thing, I need to send it here, I need to send it here, and I need to send it here. And I told you we could do it with Lambda functions. Well, we can, but we need to schedule those Lambda functions. Do this first. After this occurs, do this. After this occurs, do this. And after this occurs, do that. So if we want to add some application logic, we use something called step functions. And step functions let us sequence Lambda functions. So step 1, step 2, step 3, step 4. And this is really brilliant. So if Lambda functions are cool and every cloud has their function thing, and we can now sequence them in step 1, step 2, step 3, step 4. Now just think about how brilliant that really was. So loving it, loving it, loving it. So keep that in the back of your mind. So with step functions, we can enable a multi-step workflow. So what's it going to look like? We design the steps, right? We create our individual Lambda functions. We configure the workflow step 1, step 2, step 3, step 4. We connect the workflow components, and then we execute the steps under normal use. And guess what? We've got it running. And then all of a sudden, we determine that our workflow could be optimized. We optimize. So same thing. It's always a state of optimization. In fact, in architecture and engineering, I'll bring you to the Air Force OODA loop. So the Air Force has a concept called an OODA loop. Observe, orient, decide, act. Well, when you're setting up a step function, a website, a new database, observe it. See what's going on. Make a decision and act, make it better. So, every day learn something new. Every day work on making your system better, harder, more secure, more available. you should always be thinking about how we make things better. And that's what step functions are for. So visually, step 1, Lambda function. Step 2, Lambda function. Step 3, step 4. Step functions. Okay, so let's talk about recognition. Amazon Recognition is a way to analyze videos using machine learning. It can identify individuals in the video, people you want or people you don't want. It can look at people with facial expressions. Maybe somebody's doing this in the video and you don't want it. Maybe you got smiling people, whatever. So maybe you got somebody's content. I interviewed someone, and in the back while I was interviewing, there were bongs all over the room. Now, granted, if you're producing a video, it would be cool if we could look for content like that and remove it or not have it in there. What if I want to search for a person? I can do that. Look at logs or logos, make sure they're consistent. I can do that with recognition. So nice, beautiful pattern matching thing. And that's what we're talking with recognition. So, okay. Now, the next thing I'm going to tell you is something called CloudFormation, which should be something you should never, ever think about or use ever. And I'm going to give you the reason why. This is 100% AWS proprietary coding on AWS. 87% of customers are not AWS proprietary. So this is trash, 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 trash. Replace this with Terraform, which works on all clouds. So your DevOps engineers that are using Terraform, or even your cloud engineers that are using Terraform, they use Terraform and they can build it in AWS. And if it doesn't work out with AWS, guess what? They can go to any cloud provider they want, anywhere, anytime. So never limit yourself. Don't handicap yourself. Don't handcuff yourself to a tree, chop off both of your legs and say, hey, guess what? I'm using a proprietary service. Use the vendor neutral, interoperable, use Terraform. So CloudFront is a means to use infrastructure as code in a proprietary manner on the AWS cloud. You make a simple text file via supported programming languages. And from there, you create it in either JSON format or YAML template. But wait, doesn't the other ones use something else like Golang? But either here. Your code is stored on S3, and the code can be used by a CloudFormation template from the CLI or the API, and it's going to provision your system. Like I said, worked great, but it's only AWS proprietary, and nobody's crazy enough to just use the cloud. So scrap this, toss this AWS CloudFormation template away, trash, 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 replace it with Terraform, and you now can work everywhere, anytime, which raises your value as a cloud architect. As a cloud engineer or a DevOps engineer. Be able to work in the good stuff. So let's now talk about the certificate manager, another important service. So when you're dealing with web stuff, you want to deal with HTTPS or secure sockets and TLS certificates. So when you have to go to a website that's SSL based, you have to be able to verify the authenticity of the website, and they need to verify you. And this happens via SSL TLS certificates. So the AWS Certificate Manager is a great place to get a certificate for your AWS resources. It's quick, it's efficient, it's awesome. And, the Certificate Manager gives you free public certificates, but you can also get private certificates for your internal stuff as well. So great store. Here's how it works. Here's what you do. You go to the Certificate Manager and you request your certificates, and they give them to you. Great service. That's all you need to know. Now, when you're dealing with the AWS Certificate Manager, there's two options. There's the Certificate Manager. You want an SSL TLS certificate? Perfect. You want it deployed in your load balancers, your CloudFront distribution, your API gateways, whatever? You get it completely from the AWS Certificate Manager. Now, what if you wanted a private certificate, an internal certificate, and you wanted to create some organizational hierarchy, for example? And you want to issue certificates for certain users or their computers or their appliances or applications or services. Now we can get a private certificate, which we have to pay for, but that's okay. But we can't use a private certificate on the internet. Just keep that in the back of your mind. I'm going to talk about 3 more proprietary Amazon security services. There is Amazon Guard Duty, which can help monitor your AWS accounts. It'll analyze your CloudTrail logs, your DNS logs, your VPC flow logs, and it's going to look for patterns of behavior that are compromised. And it will tell you so you can fix it. Again, you're going to get a lot of this stuff out of good, strong next generation firewalls. There's also another Amazon security service called Inspector, which is an automated security assessment that theoretically can improve your security and compliance of your systems. Basically, what it does is it automatically assesses your applications for exposure, vulnerabilities, deviations from best practices. And after performing the initial audit, it'll give you its findings. So keep that in the back of your mind. And lastly, Amazon Basic is another fully managed data security and privacy service. What it does is it will look at your S3 buckets, and it's going to look for encrypted and unencrypted and public key things. And it'll apply some machine learning and pattern matching techniques to identify a view of any kind of sensitive data, personally identifying information that is open and available for the world. So I'm going to stop and take a few minutes of questions. Then we'll talk about cost management and 2 minutes of high availability, a couple minutes of high availability. And then from there on in, we will talk about passing the exam, and then you'll have a great weekend, everyone. So let's bring in some questions for a few minutes. See if there's anything else. We can use Lambda to do some optimization and tuning and some self-healing. So if I understand your question, I think I understand your question, and the answer is yes. Any other questions? Because I'm happy to answer them before we go on to the next topic. So I see there's a CloudFormation versus Elastic Beanstalk. They're very similar, but not exactly. Elastic Beanstalk is basically you just upload some code and it's going to theoretically design and architect it perfectly for you. CloudFormation is when you know exactly what you want and your DevOps engineers creates it as infrastructure as code. Now, truth be told, CloudFormation is a million times better than Elastic Beanstalk. But the key is CloudFormation is AWS proprietary and Terraform is not. So 99% of organizations don't use CloudFormation. They use Terraform instead for that reason. It gives them much more flexibility and opportunities. Great question there, Calpsoni. Let's see what else we have.
So this is saying CloudFormation is infrastructure as service. Beanstalk is managed app service. That's what it says.
I don't know if that's what it is because it could be CloudFront, CloudFormation, Cloud anything. So in general, we never use, as architects, we never use any kind of acronym because right now, you and I think it's cystic fibrosis. You think it's CloudFront. It could be CloudFormation, and I can give you at least 15 more. BS, I can give you what I actually think it is, but I'm not sure what he's actually trying to mean. He could mean bachelor's of science. He could mean BS in the way I'm actually interpreting it. But I also don't know if he means basic service. I still don't know. So it's really hard for me to work with acronyms and try and understand them. A long time ago, I learned a very valuable lesson not to use them. And here's how I learned them up and running. About 20 years ago, I received a phone call at 3 o'clock in the morning. And one of the engineers in the team said, Mike, I'm having trouble with all these PVCs. And I said, give a lidocaine bolus at 1.5 milligrams per kilogram and then start a drip. And he said, what do you mean? I said, you've got too many premature ventricular contractions. I don't want to deal with the VTAC. So give a lidocaine bolus and then start a lidocaine drip. And that's what happens. I wish I understood you up and running because you seem really smart. You've had a lot of great things to say. I just don't understand. Oh, okay. So CloudFormation, infrastructure as code. Yeah, Beanstalk, managed application service. Absolutely, completely agree. Yes, yes, yes. Is AWS spoken similar to Adric Logic? Yes, exactly. Same concept. All these clouds are the same. They just name the things differently. They're all identical. Okay, so do me a favor. Vote on your next boot camp. Google Professional Cloud Architect, Azure Solution Architect Expert. You be in charge. We're going to do it. We're going to do it all free. It'll be live and it'll be fun. So vote on your next boot camp. We can't wait to see you. I see some zeros. I love them all. They're all the same to me, but I'll do whichever one you like. First cloud I worked on was the Frame Relay Cloud, the ISDN Cloud, the ATM Cloud, the VPLS Cloud, the BGP Cloud. I've been dealing with clouds. Okay, so, here's the thing. McBee, this is a really great question. So what is a point of presence? A point of presence is generally where you take a bunch of internet service providers in their WAN and they all run cross connect. So you take a building. In the building, you put NTT, you put Telefonica from Spain, Singapore Telecom, Vodafone, Orange, Etisalat, Verizon, AT&T. You bring them all with these 100 gig connections all into a building. And then what do we do in this building? AT&T and Verizon run a fiber optic 100 gig cable between them. We run a 100 gig cable between us and NTT, et cetera, et cetera. That's a point of presence. Now, McB, if you were going to make a content delivery network, where would the smartest place to put your content delivery network be? In an internet point of presence. So when you're dealing with people that actually label things intelligently and call things like Azure, who don't make up names, Azure calls their edge locations points of presence because that's what it really, really is. But AWS never calls anything what it really is. They add the word elastic. They make up fancy marketing terms. So they came up with the term edge location. But really, it's just a point of presence. Excellent, McBee. Excellent, excellent, excellent question. Really good one. So we're going to get to the next content soon, but if you can give me a hashtag cloud hired and a hashtag with a career you like, cloud engineer, DevOps engineer, cloud architect, with a hashtag, give us that in the chat box and we'll get back to the content. Okay, so now we're going to talk about cost control. Now, when we do this, we're going to be talking about a lot of proprietary services that can help you optimize cost according to the AWS way of doing it. Now, this does not include negotiation. This does not include other cool things that you can do if you really know business and you're capable. This includes the stuff on cost management that's part of your certification exam, and I want you to pass it. But don't use these things in real life. And what we're going to talk about first is the changing in cost structures. Now, moving to the cloud has a very profound effect on an organization's technology cost. Huge, huge, huge effect on an organization's technology cost. In many cases, going to the cloud will be a lower total cost of ownership. In many cases, but not always. The cloud can be more expensive under some use cases at all. One thing is for sure, I'm going to tell you this right now. When you go to the cloud, it changes your cost structure from a capital expense to an operational expense. Now, other certification courses are going to say, this is great. Well, not really. Going to the cloud goes from a buying decision to a renting decision. And is it cheaper or smarter for you to buy a house, or cheaper or smarter for you to rent a house? Well, the answer is it depends. And going to the cloud can be the best thing financially or the worst thing financially based upon use cases and patterns. But just shifting from an OpEx or operational expense to a capital expense per second is not necessarily a good thing or a bad thing. It's just a thing. And you need to know that. And the organization's weighted average cost of capital and use patterns will determine that. So don't just say, hey, it's good to go to the cloud. If you do, your replacement will thank you for the really nice job that they got, because as architects, we need to know the business. So when it comes to cost management, let's talk about the traditional environment and why it's a very high capital intensive approach. In the traditional data center, you've got to buy your physical servers, your routers, your switches, your firewalls, your load balancers, your IDS IPS systems, your racks, power distribution units, your generators or backup generators, your transformers, and your battery backup to your generators. Then you need 1,000,001 air conditioners, redundant air conditioners, and real estate. So building a data center is capitally expensive. But remember, I could go right now and buy a refurbished server that has two E5 2680 V3s, 256 gigs of RAM and 3 SSD drives. And I can buy that for $1,800 once, or I can run that in the cloud for $1,800 per month, every month for years. So it's not that the cloud is cheaper. Now, if on the network, I have to hire 10 CCIEs at $250,000 each, and I need 100 people to maintain things, and I need to buy all these routers, switches, and electric, then paying 10 times more for a service in the cloud might still be cheaper. And that's the analysis. That's the business case that the architect needs to do. It is not straight and cut and forward at all. But one thing that's straight and forward at all is, in the data center, we got to buy a lot of stuff. On the cloud, we don't have to. Now, in the cloud, we pay 10 times more to use the stuff than we would to buy the stuff in that data center. So it usually works out, and it's still usually cheaper in the cloud because of the management, the overhead, etc. So in the data center, we don't have a lot of OpEx, but here's what our OpEx is: electric bills and WAN connections, and our huge staff to do it. But most of our costs in the data center are equipment or capital expenses. Now, when we go to the cloud, we're not buying anything for the most part other than the routers that connect to it, which means low capital overhead. But on the cloud, we pay out the nose to use it. So extremely high ongoing expenses. Think about it. If you're a landlord and you buy a house and it costs you $2,000 for the house, you can't rent it out for $2,000. You got to rent it out for like $3,000. So if AWS buys a server for $50,000, they're going to be renting it out and getting a few $100,000 for the server in order to make it work. But they manage almost everything for you. You need less staff. So the trade-off is usually still cheaper on the cloud. So how do you manage cost on the cloud? Plan it. So first step, provision only the resources you need. So don't do it. In the data center, we got to build for Christmas or peak. In the cloud, we can plan for average and we can auto scale. Keep that in mind. Now, the next thing you want to do is monitor your systems constantly. Here's why. If your systems are running at 10% utilization, you can use smaller systems and save some money. If your systems are running at 80%, you need to go up to a bigger system or add more systems. And you won't know that. Now, if you monitor your systems and you know what you're using, then you can properly size your resources. So that's step 2. Size your resources based on exactly what you need after monitoring. Base your systems on aggregate or average usage, not peak usage, and use auto scaling. Decouple your application architecture, so use the queues when you can. It enables you to use smaller systems. Now, use the right platform, and here's what I mean. If you know you need 10 web servers at all time, don't use on-demand. Use reserved instances. If you know your capacity, buy them with a commitment. If you need the server for 3 years, buy it for 3 years. It'll give you like 40% off. If you've got batch workflow stuff to do, and it's not critical, use spot instances. They're really cheap. Use on-demand for things that you're not sure until you're sure. So we've got lots and lots of cool stuff we can do here. And I wanted to keep that for you there. You know what your best is on average? It's going to be a combination of on-demand, reserved, and spot. So purchase what you need and only what you need. Remember, this is the cloud, not the data center, so we can grow quickly. We don't have to overbuy. Now, when you use managed services and serverless, 2 things occur. It generally gets a little cheaper, but you're also vendor locked in. You're like a prisoner to the cloud. Your handcuffs are on. You can't leave. So I don't use managed services whenever possible because I don't like being locked into a vendor. I want to be able to negotiate with 2 vendors with my customer and say, guess what? Amazon and AWS. You know, AWS, you're overcharging me. I'm going to make a press release to go to Azure. Oh, no, don't do that. That's what AWS will say. You can't issue this press release. How about a 48% discount? So when you have 2 clouds, you can negotiate against each other because the press release to going in another cloud can cost billions of dollars. But you're on AWS and you want to leave, your hands are tied, it's going to cost you a fortune. So according to the class, use managed services and serverless. Use so with extreme care because you may be locking yourself in. Step 5, In the normal network, you pay for the network, you don't pay to use it. But on the cloud, you pay to use it. So figure out a way to manage your interregional transport costs. Use CloudFront to serve content locally. Maybe replicate your static S3 buckets across the region so you're not constantly pulling data, And then think about your networking connections to the cloud. If you're using a little, it's much cheaper, for example, to use a VPN. But if you're using a lot of data, it might be cheaper to use a private line or a direct connection. Because when you're dealing with AWS, they don't just pay you for the connections, they actually pay you to use them too. So, it's not like normal networking. And what do I mean by that? So you understand? Let's say I get a 10 gig link to Chris's house over where he's at in Florida to me. Let's say over this 10 gig link, I pay $5,000 a month. Now on this 10 gig link, I can send 10 gigs, 24 hours a day, 7 days a week, and I don't pay any additional money. Now, when we go to AWS, I still get that same $10,000 connection from me to AWS. But something changes. Now, AWS, in addition to paying the 10 grand for the connection, they charge me each day, they charge me a port fee to have it there. And then AWS actually charges me to use my connection. So as you can see, when you're dealing with the cloud providers, it can get real expensive really fast. So be careful with your networking. Now, one of the things that I like to tell my students is whenever they're doing labs, create a budget. Here's what it is. You say, I'm willing to spend $15. And when you get to a certain threshold, it'll send you a message that says, here, you spent $10. Do you want to continue? So I usually recommend using a budget when you're setting it up for these reasons. So kind of keep that in the back of your mind. There's also an AWS service called Trusted Advisor. And basically, what is Trusted Advisor? It scans your infrastructure and makes recommendations. So here's the thing. Automated anything, never good. So let's kind of keep that. So now we're going to talk about building high availability architectures. And this is going to be an interesting conversation. So when we talk about this high availability architecture system, which we're going to do, we're going to have to get into that. So I'm going to get into that next. So before we do that, are there any other questions before we get to this next topic? Because it's a big topic. So if there's any questions, great. If not, I'm going to remind you, please make sure you download the completely free AWS Certified book, Soothing Relaxations. We are straightforward. Our 30% off applies to everything, every payment on a payment plan or a single payment plan purchase. And everything we do does that. We are 100% straightforward, honest, and ethical in what we do. If we say 30% off, it can't just be on a single payment. It must be all payments, because otherwise it wouldn't be fair to you. It wouldn't be a real 30% off. It wouldn't be ethical, and that's not us. Great question there, Soothing Access. Just applies to all payments. What is my advice on cloud security versus cloud architects? Well, let me tell you, I don't think you can be a cloud architect without knowing security. So at least when I train my cloud architects, every one of my cloud architects has the security skills of a security architect. They have the networking skills of a junior network engineer or a network engineer, and they all have the cloud architect skills to be successful. When my students take the CISSP certification, which a lot of them do that want to be cloud security architects, which I have in my program, they call me up and they say, Mike, I was told by everybody the CISSP was a real exam. And it's basic. And they say, my God, I learned more in your first two classes than this entire CISSP curriculum. So the key is security is critical to the architect. And we teach extreme security in all of our programs. Cloud security architect, cloud architect, they're both. One focuses on security, one focuses on end-to-end design. I'm an architect forever. Security is so critical to me that I always focus on it. So pick which one you enjoy more. Either case, you're good. Before we get to the next content, 30% off on all of our programs, payment plans, regular plans. You want to be a cloud architect and get your first cloud architect job? We have the Cloud Architect Career Development. Want to be a cloud engineer? We've got the Cloud Engineer program. Want to be a leader and take on a leadership role, move up into a senior role, we've got the Tech Career Accelerator program. Want to master and get hired in an interview? We got the Tech Interview Mastery program, all 30% off. So join us. Okay, so now we're going to get into high availability. And this is where I have a lot of cognitive dissonance, because when I tell you the ways that AWS recommends you build a high availability architecture, it makes me cringe inside, because I would never do it, because it's all really, really, really bad advice. So I'm going to tell you what you should do, and then I'm going to tell you what to do to pass your exams. What should you do in real life? Never, ever place all your eggs in one basket. So if you're going to back up your data in a company, don't store your backups in the same building that you're in case the building gets a flood or burns down. You lose everything. Never design a network with a single service provider. Nobody would do it for 30 years. You'd be crazy. So when we build networks and we have WAN connections, we always use 2 to 3 service providers, because if a service provider goes down, we go down. Okay, keep that in the back of your mind. So the concept of designing a system on a single cloud, I'm going to tell you right now, is insane. I don't ever recommend you do it. I've told people forever not to do it. Azure says don't do it. Google says don't do it. And AWS is the only company in the world that says, here, you can place all your eggs in one basket. Trust us, trust us, trust us. So if it matters to you, do multi-cloud or hybrid cloud multi-cloud, not a single cloud. If you build your systems on a single cloud, you'll pass the exam, but your replacement will thank you when you get hacked. So again, I don't recommend this. So now we're going to talk about the AWS proprietary stuff in the AWS environment, etc., etc., etc. And then I'll give it to you. So we'll talk about high availability architectures. If somebody's asking me the CCIE versus the AWS Certified Solution Architect Professional, well, when I did my CCIE, and my number is 7417, back when it was a 2-day exam, I read over 100,000 pages for it. The Certified Solution Architect Professional, we can squish down into 450 pages. So it's not even 2% of what a CCIE is. So up and running, that'll help you understand that. This is nothing compared to a CCIE. So now going back to the tech here, now that I've told you never to do a single cloud under any circumstances whatsoever, now I'm going to tell you the stuff you need to know for the exam. So according to AWS, we'll talk about availability. Now, availability refers to the system being there when you need it. So we've got 99% availability, which is 2 nines. We have 99.9%, which is 3 nines, 99.99%, which is 4 nines. This is where the world starts to think about high availability. I don't consider this high availability yet. Then we get into 5 nines. Now, this is where I consider high availability. This means 99.999% of the time the systems are up and working. Now, most people, like I said, would consider 4 nines or 99.9%, 99% to be good. But imagine you're a hospital. 99.99% of the time means in 52 minutes of downtime per year. If your systems are down for 52 minutes in a hospital, somebody's going to die. So this is obviously not good. Now, how about a bank? How about a bank being down for an hour? Well, millions or billions of dollars can be lost in a bank in an hour if their systems go down at the wrong time. So what is high availability? It's different based upon the business. And if it really matters, use 2 clouds, or a data center in a cloud, or a data center in 2 clouds. But we're talking about the AWS recommended ways as part of their certification exam. So here we're going to do this. So when we talk about high availability, this is what I want you to understand. When we're dealing with 99% availability, this is 3.5 days of downtime per year. When you're dealing with 99.9%, this is about the best you can hope for in your home internet connection. 9 hours of downtime per year. Now, when we start to build for higher availability, 4 nines gives you 52 minutes of downtime per year. Now, I'm going to tell you, no cloud provider delivered 4 nines last year. Not a single one. No matter how many availability zones or regions, none of the cloud providers were able to do this. Why? Because the single cloud is a single point of failure. Now, 5 nines availability is 99.999%, which is 5 minutes and 15 seconds of downtime per year. You got to understand that. So we're talking about critical systems and critical availability. You shouldn't be using a single cloud. So what goes into building a high performance, high availability system? Redundant power. Remember AWS tried to tell us their global network outage was caused by a power failure? Well, here's the thing. In a real data center, for real, you've got 2 power companies, multiple transformers, multiple generators, multiple backup generators, and multiple backup batteries. So I've never seen a data center power outage in 25 years, except for AWS. Then air conditioners, we need redundant air conditioners. Networking connections, we need lots of them. Routers. On our routers, we not only need redundant routers, inside the routers, we need multiple control modules, multiple line cards, multiple power supplies. Same thing for our switches on our servers. Yeah, plugged into multiple outlets, load balancers, DNS, redundancy storage, redundant databases, everything we need at least 2. 2 is none, 1 is 1 is none, and 3 is greater than 2. So always more than 1. Now, according to AWS, they have redundant power, even though they had a power outage. I'm sure they have redundant power. I don't know why they had an outage. AWS will maintain redundant cooling. Of course they will, because if an air conditioner goes down, guess what? Other systems go down. Now, AWS is going to have multiple redundant connections on their background. Realistically speaking, they probably have 10 100 gig connections between every switch, and that's still not enough. They're going to redundant routers, redundant switches, line cards, power supplies. Now, according to AWS, if you want a high availability system, 99.99%, spread your things across 2 data centers, otherwise known as multiple availability zones. And according to AWS, that'll get you to 99.99% available. Now, mind you, AWS couldn't do it last year, Azure couldn't do it last year, and Google couldn't do it last year. So if you think you can do it on a single cloud, you can't. But you know, for your certification exam to get to 99.99, use 2 availability zones. Now, AWS would tell you that if you did 2 regions and 2 availability zones per region, then you'd be at 99.999% or 5 nines. Okay, that means 5 minutes to 15 seconds of downtime per year. Has the AWS been able to deliver that? Of course they can. And here's why. When you have a single cloud, you have a single network backbone. And if any part of that backbone goes, you lose the entire cloud. If the cloud provider gets hacked, which is probably far more likely than a power outage, the whole cloud can go down. Now, if something gets involved in the orchestration or the control plane of the cloud, the whole cloud goes down. So clearly, putting all your eggs in one basket is insanity, and I don't recommend it. But now you know, for high availability in AWS Cloud, according to the certification exam, multi-AZ gets you to 99.99% or 4 nines. Multi-region and multi-availability zone gets you to 5 nines, 99.99%. Keep that in the back of your mind. So what else? Well, you're going to build the high availability system to the cloud. What about your network connections? So you're not going to have an AT&T connection to the AWS and another AT&T connection to AWS. That's insanity. You're going to have an AT&T direct connection and a Verizon direct connection because they have to be across different service providers. Because otherwise, when AT&T has a problem, you'll be cut off if you use both AWS. So then the routers that connect to the cloud, guess what? Multiple power modules. Why? Because if power supply goes down, you don't want your cloud thing going down. Multiple brains or control modules. Why? Because if one goes bad, you don't want your systems going down. And ideally, spread your connections across multiple line cards too. So if a card goes, you're bad. So realistically speaking, this is how you build high availability. So kind of keep that in the back of your mind. And we can talk about multi-cloud a little bit. So according to AWS, they would consider this to be a high availability connection, and this could work. You know, we've got lots of organizations that connect to the cloud via direct connection and use a VPN for backup. That can work for customers that don't have any critical systems. But more realistically, what I'm dealing with this. I'm needing to need a direct connection or multiple direct connections that go to one environment, another direct connection that goes to another environment. And this is really what I'm going to use. And I'm going to use this to connect to AWS, and I'm going to use a similar solution just like this to connect to a second cloud for my customers, because I'll never do a single cloud, ever. Even when people ask me to do it, I'm like, well, I want to let you know, if you want me to do this, most likely you will be hacked or you will go down, and when you're down, people will die. Are you sure you want me to do that? And because I deal with a lot of medical institutions and banks, and once I tell them that, no, they're like, no, thank you, Michael, I don't want that. Now, what goes into high availability? Security, right? If you get hacked or your system's up, nope. So use the principle of least privilege. Use next generation firewalls, not cloud native services. Disable unnecessary services. Use your intrusion detection prevention system. Patch new systems with security updates. Limit the blast radius of problems using something called AWS organizations. Keep unwanted traffic out of your subnet with an access list. Keep unwanted traffic out of your servers with security groups. Use a next generation firewall. Use Shield for DDoS protection, IDS IPS systems. Physical security. Make sure that nobody can plug into the devices that are getting to your routers. Lock them in the building. Heck, hire some Navy SEALs if you have to guard it. Do whatever you need to based upon your security requirements. When you need a password, use a password, but make it a secure password. And guess what? When you're done with that, good. And when you've got good known configurations, have your DevOps engineers template them in Terraform so you can deploy them the right way every single time. Now, what about your data? Back it up, back it up, back it up. Now, here's the option. If you back up your data in your same building and the building gets a fire, you lose everything. So when it comes to backing up, here's what you should do. Back up images of every server you have. Back up all your data and your databases and send it to a secure location. If you're all on the AWS cloud, send it to Google. Put it somewhere else, just so that you've got a disaster recovery environment. Remember, 1 is none, 2 is 1, and 3 is far greater than 2. So add some auto scaling to your infrastructures. Why? If they get overloaded, guess what? If they're overloaded and we do this, we are in a great situation. So keep that in the back of your mind. So auto scaling, decoupling, etc. Use DNS instead of an IP address because it's easier to use. Use load balancers. They're one of my favorite devices. Why do I love load balancers? Well, they improve performance and they decrease single points of failure. So load balancers are good. Now, what else? Logging. Why are we going to log? Because the logs will tell us if something's going to go wrong before it goes wrong. We're going to look for systems alerts. We're going to look for security breaches. We're going to monitor performance and usage so we can be proactive. It goes back to that Air Force OODA loop. Observe, orient, decide, act. That's why we're monitoring, logging, etc. Now, here's the key. We're going to talk about change management. There is no high availability system that doesn't include change management. Here's what change management is. Let me see some of the people that are in the group. Okay, we got Martin, which is it's more like Martin. I always get his name wrong. He's an incredible guy over there in the Netherlands. Super smart architect, wonderful person, and technology professional. We're thrilled you're here, Martin, and I'm sorry if I've got your name wrong, pronounced wrong. So if Martin wants to make a change on the Go Cloud Careers system, and he's part of our family, he should send an email that says, hey, Go Cloud Careers people, guess what? I'm going to make this change. Does it affect you in HR? No. Good job. Does it affect you in finance? No. Great job. Does it affect you here? No. Great job. So keep that in the back of your mind. And that's what we're talking about is change management. So, we're really going through things. So I'm going to talk about passing the exam for a minute, and then I want to go back and answer questions. So passing the exams, here's what I'm going to say. These exams are as following. They are the most silly exams I've seen in my 25 years of certification. The questions can cover a wide variety of meaningless topics on and off of the AWS curriculum. The questions are not difficult, but understanding the way they're poorly written is a challenge. They're super wordy. There may not be a good real answer. There may be some answers on the way you do it in the data center versus the Cisco way, et cetera, et cetera. So my recommendation is as following. Get a practice test, learn the way AWS asks questions, practice that practice test, and when you're done with it, forget about the certification and focus on learning your career, because this isn't too related to anything we do, but we still have to pass it because we need the certification for the following. Certification gets us an interview. It won't get us hired, but it gets us an interview. But if we can get to the hiring manager and then we build the skills and learn the skills to get hired, that's how you're getting hired. So we teach the skills to get hired around here. So keep that in the back of your mind. So the night before, get some sleep. Read the book that goes along with this presentation. Look at all diagrams. Read the AWS white papers and look at their services. Get a practice test, get a practice test, get a practice test. Haman Sharma from Review and Prep has some excellent good practice tests. They're $15 to $20 and not a big deal, and they're not super expensive. Andrew Brown of Exam Pro as a completely free AWS Certified Solution Architect Associate course. He and I are friends, and sometimes his course is free. And I think for $20, it's got a great practice dictate. Take that with mine. His is all about passing exams, and mine's a little bit more about how to actually work. So go take the exam, go pass the exam, and be solid, 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 and you'll be good to go. Now, on the day of the exam, get there early, in person or not. Trust me, the tech won't work. You can run into ID problems. Don't forget your ID. So give yourself time so you are relaxed and stressed. So we have reached a point where I am going to answer some questions. We've had a fun, exciting week. If you've had some fun, if you can give me a like, a comment, or a subscribe, so we know that you're there. And now I will start answering people's questions. And I absolutely love answering questions. So let me know what kind of questions I can answer. Thank you, Marjan. Please hit the like button, show some appreciation for us working really hard. And why do I really care about it? So we can spread the word of others and other people can see it. We work hard to help the people in the developing world. Zim Can IT. How do you keep tabs of all the services running in AWS when working with a client? Well, Zim, I don't, because I'm an architect and I design the system. So I design the system. And once I'm done with the design, I never go back to them. So I don't have to keep track of all the systems running in the AWS environment because I ask it as part of the design. I baseline it with my cloud engineers. I design an architecture, I present it, I sell it, and I'm done. Now, if I was working in a maintenance role like sysops, what'll happen is there are actually really good network and systems management tools, not AWS tools, but systems management tools. And they will monitor, like Zabbix is one, but there's other tools. They will monitor your systems in that data center, the cloud, and 3 different clouds, and they're going to be able to help you keep track of what's going on. But here's the thing, Zim Can IT, when I actually design an architecture, it usually includes a massive, not only diagram, but a document that's massive for the engineering team, a document that's for the executive team, and it lists and explains everything that's running. So there's never a time as part of a good architecture where people don't know. But Zim Can IT, let me explain. There's basically 3 roles that we're dealing with. We're dealing with the architect that designs the system, the engineer that builds the system, and once the engineer is done building it, they're kind of done. It gets handed over a maintenance team called sysops, and that's who manages it. So kind of keep that in the back of your mind, and that's how that'll determine how you need to know it based upon the tools you need for your job. Great question, Zim Can IT. Chris, if you want to bring in the next one. Marjan, I'm so good. I'm so happy and thankful if I got it right. William Soti, please, did you say 99 high availability is a result from 2 availability zones regions? Yeah, according to AWS, you can get high availability 99.999% by using 2 regions and using 2 availability zones and regions. Now, having said that, they didn't do it last year. They didn't get to 4 nines last year. Azure didn't get to 4 nines, and Google didn't get to 4 nines. And getting to 5 nines on a single cloud, I'm going to tell you, is pretty much impossible. But, Amazon says they can do it by using 2 availability zones and 2 regions. Chris, do you think that's correlation of decoupling and autoscaling? I'm not sure.
That's how I interpret it.
So if it's correlation between decoupling and autoscaling, there is none. I mean, decoupling is this. Take 2 things and separate them. So have a sniper and a spotter, 2 people on the same team. Have an architect and an engineer, 2 people on the same team. That's decoupling. Autoscaling is this. Have your systems, they run, and all of a sudden they're very busy, so go add more of them. So they're kind of different. Now, the only way you can relate these 2 is as follows. You could use something like an SQS queue, which is part of decoupling the organization. And the SQS queue could say, hey, wait, we've got a lot of messages, enable auto-scaling. But, that's a use case of an SQS queue. It has nothing to do with decoupling and auto-scaling. But it's really a great question there, Cecil. Calpsoni, as an architect, you know you need to be really good and creating on documentations as well as presentation, sales, all of it. And of course, we cover that in our Cloud Architect training program. We cover presentations and skills and documentation, and RFIs, RFPs, RFQs, how to negotiate, how to present to the CEO, CXO relevancy, whether you're dealing with analytical leaders versus intuitive leaders like me versus functional leaders, whether you're dealing with visual, auditory, kinesthetics, how to read the room. Yeah, all that stuff's in there, Calpsoni. I mean, this is a $50,000 program that we basically charge $700 for. And we're only doing it because we're basically charging what it costs us to do it. And we're dealing to help the world get hired. See, I felt really bad. I saw the certification that was out there and I knew none of those people are getting hired. I even interviewed 1,000 AWS certified people that couldn't get hired. And I knew why after speaking to them. So our Cloud Architect training program and our Cloud Engineer training program give the people the skills, all the skills they need, so they're going to get hired at the end of the program and be good at their job. And of course, we cover it heavily, heavily, heavily. That's exactly. Once the design is done, we're gone. Somebody else is, we go to another customer. It's exactly the job. Good news is you get to meet lots and lots of executives along the way, which means you build a super Rolodex if you ever want to be a CTO or CIO. Definitely true. Good question. So, Chris, you can bring the next one in. So no, realistically speaking, as a cloud architect, all we're going to do is go design it, and we're going to have another team that's going to build it, and that's going to be an engineering team. In 99% of all cases. Now, there are 1 or 2% of the cases where they tried to have the architect build it, but let me tell you, that is a disaster waiting to happen, because as soon as the architect gets involved in building, they lose all function of what's going on. They design disastrous architectures, they have big outages, and they get fired. So here's the thing, up and running. Architects design and engineers build. Chris, we can go to the next one. Mike, in the earlier slide, putting security together, you saw network load balancers outside the firewall. Why not put load balancers inside the firewall? So Brian, I'm going to ask you this. In a data center, we can hang 2 firewalls in the rack, and it's all good. But in AWS, we can't add them. So when we go to the marketplace, we're getting a virtual machine. Now, the whole point of the load balancer, Brian, is if we've got 2 virtual firewalls and the firewall one dies, if we don't have a load balancer, we lose all our security. So by using a load balancer, and it must be outside the firewall, we can send it to firewall 1, firewall 2, or firewall 3. And maybe we need the performance of more than one firewall, so it has to be out there. Or we also need a second for redundancy. But in any case, we can't send the firewall in. We don't want to send it to a firewall that dies and then it's going to go to the load balancer. We have to use the load balancer to front end the virtual firewall. So if a firewall fails, when the load balancer runs its health check and it sees that the firewall fails, it redirects everything to the other firewall. So it must be on the outside. Now on the inside of the load balancer, on the inside of the firewall, we're going to have more load balancers. Like we'll have a load balancer from the web servers, but that'll be inside. But in this case, it has to be outside. Okay, let's see if there's any more questions. Actually, let me get to the one question, Zam, can IT? It's a very good question. Okay, so Zam, can IT? So the skills for a solution architect are network and data center knowledge, sales skills, documentation skills, presentation skills, ROI modeling skills, business acumen skills, leadership skills, and sales skills. We cloud architects do not code. And if you learn coding, it's kind of like a doctor saying, hey, guess what? I learned yoga. Now, I am a yoga instructor. I love yoga and I can practice medicine, but nobody's going to go to me for medicine because I said, I know yoga. And, it's like a doctor saying I'm a photographer. So when you're an architect and you learn scripting and programming, you take your focus off of architecture and you learn someone else's career, which means when you're really good at someone else's career, you can't get hired for your career, you can't get paid in your career, and you can't get promoted in your career. Because if I want an airplane pilot, I hire an airplane pilot that's an expert pilot, not a programmer. And an architect doesn't touch technology ever. They design it. So having hands-on technology skills makes you a worse architect. You need better digital transformation skills, better business acumen, better leadership, better skills. So you want to be an Olympic martial artist, study martial arts. Don't hang around and be a competitive swimmer. Be a martial artist. You want to be a doctor, go to medical school. Want to be a lawyer, go to law school. But don't go to yoga instructor school to be a lawyer, and don't learn how to code if you want to be a systems designer. Learn system design. Now, if you want to be a cloud engineer does do coding. So if you want to be a cloud engineer, you got to get great with the management console, the command line. You're going to need to know Python, Bash scripting, PowerShell scripting, Terraform if you're an engineer. So, and that's why we teach that for our engineers. So Zimcan IT, it's a matter of having the skills for your job, mastering your job and being the best in the world at your job. It does you no benefit to not learn the skills of your job, learn the skills from somebody else's job, because when you're focused on somebody else's job, you're not becoming good at your job, you're becoming good at somebody else's job, and there's no point to that. So it'll just hurt your career. Okay, so no. So Kalp, Sonny, I want you to think about this. I practice medicine. So today I'm practicing medicine. I am the architect of my patient's care. So Kalp, Sonny, a patient comes into my office and they say, I have chest pain. So Kalp, Sonny, what I do, I say, you go to the ER. And I write admission orders. I say to the ER, IV of normal saline, nitro drip, titrate to a BP of 110 systolic. Run 3 sets of cardiac enzymes and a 12-lead EKG. Kalp, Sonny, I don't have to teach the nurses how to do their job. They went to nursing school to learn how to do their job. So the doctor makes the plan and the nurses carry it out. If I build an architecture and I tell my engineers, I need this many load balancers, this much storage, this much security, they know how to do it because that's their job. So I don't know why it seems like a very challenging concept for people to understand, but let's get out of technology. A building architect, they do the same thing we do as architects. They design a building. Now, does the building architect need to tell the cement worker how to lay cement? Does the building architect need to tell the landscaper how to plant grass? Does the building architect need to teach the construction worker how to use a hammer? Of course they don't. Of course they don't. So it's a totally different job. And no, we don't need to teach people how to do their jobs. They design it. So, if you had an architect designing a building, the architect designing the building might speak to some structural engineers and contractors along the way and say, if I design it, does this work? Can it work? Can you build it? Will it work? So there is that. And truth be told, Kalp, Sonny, when I design an architecture, I do it in collaboration with the engineers. And here's the reason why. The engineers are the deeply technical people of the bunch. So when I design an architecture, the reason an architect needs to have such good leadership skills is the following. A bank says, Mike, I want an architecture, and I design the architecture. Now, then they say, Mike, I want to test it with a proof of concept. Now I'm an architect. Architects don't know how to touch anything. They don't know how to configure anything. They don't know how to code anything. That's not what they do. Their skill is design, and it's a very different skill. Design is on how it works. Building is how to build. They're like opposite skills. They couldn't be in the same universe. So the cloud architects, there's a proof of concept. I'm going to bring in 50 cloud engineers. I'm going to manage them and lead them. They know their job. I don't know their job. Kind of like if I got a traffic ticket and I wanted to go to a lawyer, I don't know what the lawyer is going to do because I am not a lawyer. I don't need to know what the lawyer is going to do because the lawyer is trained in this. So, Kalp, Sonny, there's a huge miscommunication in tech that assumes that we need to teach people how to do their jobs. We hire the right people. We don't teach people how to do their jobs at all. We hire the process. But when we're dealing with architecture, it's always going to be a collaboration. So that's really the key. I'm not going to go to a nurse and say, here's how you do your job. They don't need direction. I'm not going to go to a lawyer that's going to help me with a ticket and say, I'm going to teach you how to practice law, even though I'm not a lawyer. And I'm not going to be an architect and try and tell somebody how to do their job because I don't know their job as well as them. I'm going to collaborate with them in the design. I'm going to collaborate and ask them while I'm designing, is this going to work? But that's it. No, I don't need to know how or what they do. But you know what? When I stay in a hotel, the room magically gets cleaned and I don't know how they do it so well. I don't need to know how they do it so well. You know what? If I go to a restaurant, I don't need to know how the chef made the meal. I just need to know what I ordered. So in practicality, that's the key. If you've got a doctor and a nurse collaborating on the patient's care, or an architect and an engineer collaborating on the best design, it's all the same. I don't need to tell somebody how to do their job. And if I think I'm going to tell them how to do their job, Kalpsani, you know what's going to happen? I will be fired that day. And here's the reason why. People do not like to be micromanaged. And cloud engineers are extremely educated, professional people with a great skill. And if I sat over their shoulder trying to tell them how to do their job, which I don't even know how to do because it's their job, the only thing that would happen is they'd say, Mike, no, thank you. Now, we got to remember this, Kalpsani, as an architect, when we work with cloud engineers and they help us do our proof of concepts and designs, they don't work for us. They work for their own engineering managers. So when I call a team of 50 cloud engineers, I got to not only do this, I got to call my manager, all their managers, and say, hey, can I borrow your people? And then, Kalpsani, since the people don't work for me, I got to encourage them to work. And let me tell you, if I try to tell someone how to do their job, they won't be doing anything for me. So we don't ever need to give direction for other people how to do their jobs. The only time we give directions is if we hire a junior person and we've got to train them. But we're never going to be telling people how to do their own jobs and other careers. And that's why we don't need to know other careers. And if you're an expert at somebody else's career, you know what you're not? You're not an expert at your career. And that's why doctors don't go to law school. And that's why airplane pilots don't become flight attendants. Sean asked a great question. What does a security architect do to a solutions architect? Well, Sean, very simple. As a solutions architect or a cloud architect, we ask our customer about their business. We ask them about their business goals, their business pain points, their business challenges. And then we design an end-to-end solution to solve them. That's what we do as a cloud architect. Now, as a cloud architect, Sean, when I'm designing an end-to-end solution, I'm just one person. And one person never designs an architecture. So, Sean, I've got a big architecture. Here's what I'm going to do. I'm going to hire a cloud network architect, a cloud security architect, a cloud IAM architect, 3 cloud engineers, 2 DevOps engineers, 4 network engineers, etc. And together, the cloud architect will focus on the end-to-end, and they will be the coordinator of all the smart people. The cloud security architect, or the security architect, is only focusing on the firewalls, the security policy, the VPN design, the demilitarized zone, the access control list and filtering, what routes are filtering. They're only concerned about security, where the architect is concerned about the end-to-end business. So you notice I didn't say IAM under security architect, Sean. And the reason I didn't is there's another kind of an architect called an IAM architect that focuses exclusively on IAM systems like Active Directory and etc. So when I do something, I build an architecture team. The architect is the coordinator of everything. And we get together with security architects that do design our security, network architects that do our networking, big data architects that do our networking, cloud, our big data, et cetera, et cetera. That's what we do. Great question, Sean. Okay, so this is a great question for a data scientist. When you're dealing with life sciences, do you use tools for predicting? Well, yeah, there are tools that you could use, but they're the same tools you could use on and off of AWS. So typically speaking, for something like this, we're typically dealing with an Ubuntu Linux system with a bunch of GPUs in it that are using TensorFlow or PyTorch or something like that, that are machine learning tools and libraries that people use. And I'm not a data scientist. So AWS also has certain tools that you could use that are pre-made tools for doing these things as well. Now, realistically speaking, if you're not going to create and code your own tools, and you really wanted to do machine learning on the cloud, I'd encourage you to think about this. Who is the world's greatest algorithm maker? Google. Who is the #1 search engine algorithm in the world? Google. Who owns the #2 search engine algorithm in the world? Google. So if I was going to do a machine learning thing and I wasn't going to code it myself, do it in my data center, and I wanted to use pre-used libraries, I would be using Google because that's their whole business is algorithms. So yes, there are tools you could use, but there are probably much better tools on Google. Hey, Mike, you have so you have a certification as an architect and you work in system support. What things are necessary to acquire a solution architect position? I'm going to tell you right now, and I can't go much longer, but I'm going to tell you right now. So when you are an engineer and you're working in support, and that's typically an engineering role, the perception of you is that you're a techie, and that, that's it. So the things that we have to do to be an architect is we have to change your brand. We have to change you from a technical person to a leadership brand. And that's the first thing. So we have to go through your resume and your certifications. If you have too many certifications because you've got too much techiness, we're going to have to remove the unnecessary certifications, get the right certifications in there. Now, Colin, if you've got any of this engineering stuff out there that says worked in EBS, S3, EC2, all this, that shows you as a techie, and that needs to come off of your resume instantly. Now, we can talk about setting up server virtualization, containers, designing and building clouds, working with firewall architectures, designing DMZs, but we got to get out of tech into the transformation. So when you're trying to be an architect, you're a transformation specialist, not an engineer, not a technical professional. There are other wonderful jobs, but in this case, you want him to be seen as a business leader. So what has to happen is first, you have to go from learning how to do to learning how to design. That's the technical change. The next thing is the brand. You will need a massive resume makeover and a massive LinkedIn makeover. And Cullen, we've done it for lots of our students as part of our career development program. We'd love to do that and help you with it. But that is really, really critical things for you to do. Next, you must learn the business acumen. You need to be able to look at a balance sheet, financial statement. You need to be able to calculate a return on investment capital model. You need to be able to show customers the value of the solution is greater than its cost. You will need presentation skills, and they need to be expert, and you'll need it for the interviews. You need presentation skills training. You will need to be relevant to the CEO versus the CTO versus the CIO versus the CFO. So you're going to need CXO relevancy training. Again, we train all of this. You're going to need leadership training because you're going to be leading a team of 50 really smart cloud engineers that don't work for you. And you got to make them motivated to work for you. Because let me tell you, as an architect, our strength is how good we are with the engineers, because the engineers are the smartest people out there. And they make our world. So we help those engineers and they work with me. So kind of keep there's that. So then presentation skills, and we have to teach you how to sell. And selling a $100 million architecture is a different skill than selling a $50,000 car, for example. So we have to teach those high-end scale skills. And then we need to teach business writing. And after that, guess what? You will be golden. And if you'd like to train with us, we teach all of that in our career development program. But if not, now you know what you need to do. And you can get cloud hired as an architect. But all these careers are great. It's a matter of matching the one. For those people that are really techies, that cloud engineer job is the best job in the world. For people that need like talk and meet people and get to know people and transform, the architect job's the best world. But it's what makes you happy. That's all that really matters. So at this point, and yes, I am actually fairly tired. It's been a really, really, really long week, but I work hard to keep the energy up. And here's the reason. I've been a student too. I know what it's like to learn. It is not easy learning this stuff. And I want you all cloud hired. So I'll be sleeping half of the weekend with my beautiful cat, Cindy. She'll be on my chest and I'll be sleeping with her in a few minutes. But cloud hired, everybody. Let's get you cloud hired. Look, I love working with this community. You guys are all amazing. Be proud of yourself for sitting together all week. I mean, it's been a long week. You guys are special. I mean, truly amazing. So, you are here for me and I'm here for you. So go out there and get yourselves cloud hired. Vote on the next boot camp, because guess what? You want to know Azure, Google, I don't care. We'll teach you. We'll make sure you learn it for real and you'll know how to be hired. Cloud hired, I'm loving it. If you can all give me a hashtag cloud hired and a hashtag either cloud architect, cloud engineer, cloud admin, cloud DevOps, whatever job you love, please let me know so we can make programs and content to get you the world's best job. So thank you so much, Nina. Karan, thank you so much. Cloud of Nines, I love that. Thank you. You're more than welcome. Nick B, cloud hired, cloud architect. Sharon J, thank you so much. And yes, thank you from my team. Have a great weekend. Gilbert, cloud hired. Brian, cloud hired. Mr. Gee, cloud hired. I love that. Marjan, thank you much for this free great bootcamp. Thank you so much, Marjan. Thanks, Chris and Blue Crew. Thanks, GCA family. If possible, use this opportunity and extended 30% discount. Please take advantage of that. If you want to get hired, we really want to help you. LM Cloud. I'm loving all these cloud architects and cloud hires, but maybe DevOps, whatever you like, Sam Ken ID, just be happy. Abigail Marks is in North Carolina and up and running. Good to see you. Up and running, you're really tech, you're a smart guy, and I loved having you here. Cloud of Nines, cloud architect. Mufaz, thanks as always. I'm thrilled you're here. And yes, thanks, Blue Crew. Thank you so much there. And we can't wait to meet you, Cal, in class. Leo, cloud hired, and Brian, cloud hired. He's in Philadelphia, where I know my old stomping grounds. Gilbert, wonderful singing, and Danica, cloud. Oh, I'm loving so many people so far. AJ, hoorah! So good to see you. Robert, so good to see you. Klaus, good to see you. Cloud Architect, Soothing Relaxations, and Robert over there in the desert, good seeing you. See, if you see Isaac, my favorite IAM architect, please tell him I said hello. Robert, lovely weekend. I'll say hi to Cindy. Absolutely. Cindy is beautiful. Do we have any photos of Cindy? Jonathan Crow. Cloud hired, everybody. I love motivation too. I absolutely love it. So have a wonderful weekend, everyone. Can't wait to see you. On Monday, I'll be here to answer any cloud career questions you want from 2 to 4. Like I said, we have 30% off right now. Take advantage of it. We've got a companion ebook that goes along with this, so please get it. Happy Passover, happy Easter, happy Good Friday. Love spending the week with you all. You are all amazing. You inspire me every day with your effort and your will and your goals to go do some great things, and I'm here to help you. So get yourselves cloud hired. Take care and have a great week.